Energy. But what is energy really? Is it the jolt of strength we get before we pass the finish line at the end of the race? Is it the inspiration we get when we see something new? Is it the tireless pursuit of trying to move forward? Energy is the power which drives our lives forward everywhere. We have learned to transform it from different sources and to use it at our will. We create energy and we give it direction.
All right, now hold it down.
We are the people who develop the future technologies today. What will they be like? It only depends on us. In the last decades, the vision of energy has significantly changed in many countries. And now, in this period of evident transformation, we can't miss the opportunity to find the answers to the most important questions. What drives the energy industry? What are the directions and tendencies of the energy industry? What lies at the heart of the frontline research? Which applied technology draws the most interest for the Russian industry and for the world industry in general? The leading world scientists, together with the bright minds of the new age from universities and international companies, every day are seeking the answers to these questions. The result of their work will be presented at this international scientific practical conference, Energy Agenda of the Future. We will take a look at energy from a different perspective, in an alternative way. Welcome to the International Conference, Energy Agenda of the Future.
So, dear participants, we're happy to welcome you at the conference Young Engineers of the Fuel and Energy Complex, the Energy Agenda of the Future. And let me introduce the moderators of current session today. My colleague Dmitry Kaplun, Associate Professor at the Department of Automation and Control Processes, Electrotechnical University, LETI.
Thank you, Alexandra. And I want to represent my colleague, Alexandra Proshkina, Deputy Director of Institute of Innovative Design and Technological Entrepreneurship of St. Petersburg Electrotechnical University, LETI.
Well, thank you. And today we are going to listen to the reports in the two sections, energy efficiency and economics and new energy industrial personnel. And let me introduce the guest editor of our conference, Dr. Konstantin Suslov, head of the Department of Power Supply and Electric Engineering in Irkutsk National Research Technical University. Greetings, please. And maybe you will give a small speech for our participants.
Okay. Dear colleagues, thanks a lot for invitation. I hope this is a very interesting. It's a very interesting conference. I hope that will be very useful for young scientists. You can find a new colleagues, you can find a new friends. Maybe you make some collaboration. Why not? It's very important for scientists. Okay, thank you very much. Thank you a lot.
Thank you too. Thank you for your greetings. And now, as I previously said, today we have two parallel sessions, and one session is presented here. It is called Economics and Industrial Personnel. And the second session is led by my colleagues, AnnaKovaleva, Tatiana Kazulina, and Dr. Professor Suslov. So this session will be available at Zoom conference. And today we are going to listen some reports here in our conference hall, and also we have Zoom conference, and our colleague moderator Alexander Parin, are you here?
Yes, thanks also. I'm here and we're ready.
Yes, so our meeting will be broadcasted, and some colleagues will join us through the Zoom conference. And so after the report, you can ask some questions here or at Zoom conference.
Dear colleagues, our current event is being held under support of the Federal Agency for Youth Affairs, Rosmolodezh. Our section aims to bring together industry professionals, researchers, and proactive representatives of the youth engineering community, and to discuss the most present issues of the world energy. And we hope we will get a brilliant collaboration for the future.
And let me announce the regulatory framework of our section. According to the modern anti-COVID measures, the part of reports will be presented via online. The speaking order is stated in the conference program. The participant presented an oral presentation lasting no more than 7 minutes. So we have 3 minutes for asking the questions. So time for audience questions, 3 minutes. We kindly ask to follow this timing. The language of the speech is Russian or English. And for Zoom participants, there is available the change of the language. It will be Russian or English. So you need just to find the option in the bottom of your screen. So if you have any problems with choosing the language, you can ask our moderators, you can ask help or some recommendations. So I think we are going to start, and we ask to present the report Ms. Niemb Bekume Suzanne, Peter the Great, St. Petersburg Polytechnical University, and the name of the report, the mechanism of economic development of the energy complex for small and medium-sized businesses in Cameroon, based on bioenergy resources. Your greetings, please. And before you start, I ask to Ms. Volgapkina Anastasia to be prepared to present the next report.
Okay. Good morning, dear participants. I am Niemb Bekume Suzanne from Cameroon and PhD student of St. Petersburg Polytechnical University, Peter the Great. We offer you a scientific report of topic, the mechanism of development of economic energy complex of small and medium-sized business in Cameroon based on bioenergy resources. The relevance of topics lies that fact the storage of electricity does not alone develop a country's economic and agricultural small and medium-sized enterprise. At the same time, there are agricultural and food industry enterprise that can form raw materials for the development of bioenergy. The purpose of the work is to develop tools for managing the economic of energy complex by using the potential of energy security of enterprise. When used decentralized power supply system with the use of bioenergy resources. Object of which is fuel energy complex of small and medium-sized business in Cameroon. Subject of which is economic and energy potential of bioenergy in small and medium-sized business in Cameroon. The work identifies areas that meet the condition of decentralized power supply system for small and medium-sized enterprise. The east zone of the map contains major mining or logging activities. The central west zone, there's a larger industrial activity and high population density. The modern zone of the map, there are larger larger agricultural and livestock activities. These zones, small and medium-sized, cannot develop due to the lack of electricity. The listed type of small and medium-sized business need to create a decentralized power supply system. In order to improve the economy of energy complex of small and medium-sized enterprise, taking into account bioresource, the author believes that it would be reasonable to place companies in the main players in the development process. The goal here will be for small and medium-sized enterprise to have broad control of various activities, namely generation, distribution, and consumption of buffer of electricity. For the purpose of developing the methodologies, first it's necessary to determine the factor influencing the energy securities of implementation of the scale of functioning of the decentralized power supply system of enterprise Cameroon. A comprehensive analysis made it possible to identify macro factors that affect the energy securities of energy supply system of enterprise in Cameroon presented. The scale of companies' activities. This factor determines the possibility of exclusively independent energy generation. The scale of companies. This factor primarily determines the possibility of the independent fuel production. Geographical location of enterprise. Size Cameroon geographical interregional in terms of the distribution of energy resources. Climatic influence. This factor reflects the influence of climatic condition of the region of operation of enterprise of the process of energy generation in the energy supply system. Legislative environment. This factor is the most complex and reflects the specific of the implementation of projects on the study and the level of state support for the choose method of energy generation. In this I present methodology for assessing the level of energy security for choose the decentralized power supply system for enterprise. The methodology is a sequence of action that learn from n number of projects according to the certain rule to choose the provide level of energy security. According to the practical solution of the methodology, include the following stages. Formation of state of alternative solution for the organization of decentralized power supply system. Assessment of private indicator of energy security of decision, the organization of decentralized power supply system. Calculation of integral indicator of energy security based on the result of the calculation of each and of the particular indicator. Their values are recognized by the criterion. Selection of solution for organization of decentralized power supply system that meet regulatory values. A model is proposed for determining the boundary value of permissible or acceptable level of energy security. Model for formation of frozen multiple classified include the determination of factor, the identification of linguistic variable, basic term of set, determination of carry linguistic variable, and the calculation of particular and integral indicators. For practical calculation, a set alternative solution for organization of decentralized power supply system was formed as an assumed the private energy security indicator of decentralized power supply system was carried out. An example of 3 potential projects at this stage, it is important to confident the technical, economic, and financial feasibility of each project. Project 1 and project first and second are based in biomass classification technology. And project 3 is based on methanization technology. Using the model mentioned above, each indicator corresponding to the proposed criteria or factor integrate. The calculation of the integrate indicator of energy securities of the organization of decentralized power supply system allowed to obtain the result present in the table. Practical calculation allows us to estimate the level of energy securities for each project according to the proposed methodology. The condition of the integral indicator belonging to level of energy securities of the centralized power supply system of enterprise in relationship to project. As can be seen, the results obtained are almost identical. In demonstration, high permissible energy security for project 1 and 2, and the very high permissible energy security of project 3. These models allow us to get away from the problems of using statistical analysis tool and at the same time limit the subjective and expert indicator witnessed. Based of 3 projects as practical example in the following the implementation method. Calculation of economies indicator we carry off for each problem, as well as feasibility study of subcase exchange in the level of energy security for small and medium-sized enterprise. The evaluations result express the level of energy security calculated of 3-point scale and the level of reliability of the result obtained, characterizing the possibility of shifting the level of energy security tolerance within the permissible state. The result of the present study can be used to justify the choice of scheme for organization energy supplies to small and medium-sized enterprise, experiment energy shortage, and have the ability to create isolated energy system based on the use of energy resources. Thank you for your attention. Waiting for your question.
Thank you. And now we are going to listen to the questions in our audience. So in case of no questions from the audience, we are going to listen to the questions in a Zoom chat. Dear Alexander, please tell us if there are questions.
Yeah, we have a question from Zoom and question for Niemb. Has the proposed model been applied to real-life enterprises?
So can you repeat your question?
Has the proposed model been applied to real-life enterprises?
Real applications. What? Real applications of your model.
Applications of your model.
He means real applications of your model.
Yeah.
Do you have real implementations? Yeah.
Yeah. Well, a model for application for the small and medium-sized enterprise is for to estimate the level of energy security in the for the small and medium-sized enterprise. We use the factor. At least I speak for the factor scale of the company's activities, scale of the company, geographic location, climatic influence, legislative environment. You use this factor to calculate this, the level of energy security.
Thank you. Any other questions?
Dear Susan, I have a question. What mathematical background do you use in your study? Please explain briefly. Mathematical background do you use in your study?
Yeah.
Can you please explain briefly in some words?
We mean maybe some statistical models, some methods. Which methods mathematically you used in your research?
We use statistical models. We use experimental models and inductive models to make calculation.
Yeah.
Thank you. Greetings to our first reporter.
The next presentation is Anastasia Volgapkina from the Financial University under the government of the Russian Federation, geothermal energy comparative characteristics of Russia and the United States of America. The presentation will be online. Dear Anastasia, are you ready?
Yeah. Can I ask a question? I prepared my presentation in Russia. Is it wrong or no?
The slides of the presentation must be prepared in English, and your speech could be Russian, of course, because the translation of the speech will be done.
Okay, just a minute.
Thank you. And while Anastasia is preparing, we ask to be prepared Mrs. Marina Vlasova for the next presentation.
Sorry, it's hard. Can you help how to enclose my presentation?
You can put the button in Zoom to demonstrate the presentation, demonstrate the screen.
Просто нажмите, пожалуйста, дайте.
Share screen.
Да.
We can see you.
Yes, we can see your presentation. Okay.
Good day. My name is Anastasia Volgapkina. I represent Financial University, and today I would like to talk about geothermal energetics in general with comparative characteristics of the case in the United States and Russia. And I think it's quite interesting because development of geothermal energetics will help us to differentiate sources of energy inflow and will help us to develop various systems which is necessary for isolated areas like Chukotka or Sakhalin, and which is strategically important for development of Russia in general. I would like to talk about the trends of geothermal energetics in general. I'd like to talk about the methods used to compare the United States and Russia and separate analysis, and also like to talk about the results of the research which we've got through my research. I would like to say that alternative energetics takes more and more place in energy balance of various countries. So the production of geothermal energy was 92 gigawatts per hour with an average in-growth rate of from 33% from 2014 when countries started to switch to a low carbon economy due to the after the signing of the Paris Convention. There are several factors increasing effectiveness of geothermal energy use. There is a trend that the Earth's temperature every year increases at about 1 degree Celsius, and we've got a very important issue: how to provide more of electric power, decreasing the pollution or exhaustion. And one of the potential answers is geothermal power stations. Which methods were used to compare countries separately? We did analysis, macroeconomic analysis of geothermal power stations, the technical and economical parameters, and also we did SWOT analysis of geothermal energy situation in at the level of the country, and also identify key factors of geothermal potential and risks present, and measures which will help us to develop geothermal energy. Let's talk about the geothermal energy situation in the states. There are 7 states developing this area of energy production, but current capacity of the stations decreased and is about and along with that, in the states, you can see it on that map, that those stations are mostly located in the western part of the country, with the highest accumulation of geothermal resources. But with a green color, you see 2 states, it's Arizona and Colorado, which have not yet installed geothermal stations, power stations yet. And in the future, they could be used or installed for effective energy generation and the development of, so to say, development of, so to say, states separately from general power network in the country. And we can say that the geographic positioning of those states makes possible to develop geothermal energy, but the weakness is that it's hard to exploit those sites, since legal entities installing geothermal power stations, they should pay of about 90% of the income to the state, and due to the high risk and low income, the refusal of development of this power generation, and without proper sort of development, it might result in degradation of geothermal energy developments in the United States. Let's talk about the geothermal energy situation in Russia versus states. Our potential is lower. However, our energy capacity increased to 74 megawatts. Like in the states, it's 2,500. And so currently at the moment, we have 5 geothermal power stations, which mostly are located at Kamchatka region. You could see it's number 3 at our graph, and number 1 and 2 shows regions which possess the highest geothermal resources, and they are shown here because of the quite cold climate, and also they are isolated from the general power network. It's such regions like Chukotka and Yakutia, so it will help us to be more accurate with determining geothermal energy development strategy in Russia. SWOT analysis shows that we have lots of opportunities in Russia. However, Russia could be able to because of the hard climate conditions, they should invest more into the planning and human capital in order to improve equipment durability, thus extending its, so to say, useful lifespan. Let's make a comparative analysis comparing the United States and Russia. Here we have 4 key criteria which we use to compare those 2 countries. It's total power generation. In the States, it's about 18,000 gigawatt, and in Russia, it's only 400 gigawatt, which is a very small percentage of the total energy production in the country. And let's switch to the 4th item, which has the share of lands which could be where we could use geothermal energy versus the whole territory of the country. In the States, it's 44% of the whole country area. In Russia, it reaches 69%. So meaning in Russia we have better potential for development, but intensity of this territory usage is currently higher in the United States. So finalizing, we can say that for the states is a leader at the international energy market, but improper approach to management and economics of power stations and the way of land allocation makes problems in, so to say, in development of this area further. In Russia, we should just look at which regions to be developed, and also we should stress on investment into, as I said previously, into the human factor and in construction works and improvement of stations, so to say, durability. So it will provide independence to power isolated regions. And briefly, we should say about further potential or perspectives. We should determine a correction index showing with regard to the country development, not only the development potential for the regions, but also will take into account climate features and problems with energy or power generation. For instance, in the States, you don't need additional equipment like binary cycle devices, and brings us to the further item for research, economic, so to say, rational for those stations, for power, for geothermal stations, because it will be different for every regions, and it's very important for further improvement of competitiveness of geothermal energy sources versus other alternative power sources. It's the end of my presentation about geothermal stations. Thank you for your attention. I will be very glad to answer your questions.
Dear colleagues, do you have any questions?
No.
Yes, please.
Our volunteer, could you please give a microphone?
Thanks
a lot for most interesting presentation, and the topic you raised is really most relevant. And I have the following question. In one of your last slides, we talked about the criteria for comparison of the United States and Russia. Could you please open this table? So which was the rationale of selecting those 4 criteria? Why you choose those 4 criteria specifically, but not some others, or maybe you could use more of indicators? Well, thank you for your question. Actually, we had lots of criteria were selected initially, but I decided to use these 4 because they will make possible to rapidly collect statistical data on those elements, and you can quite rapidly assess effectiveness of both extensive and intensive development patterns for the country, because they show both general development of energy industry and development with regard to and the share of geothermal energy versus other energy generation. We know that countries might have different size and energy production or power production in those countries, or the sources of energy, they're also different.
Yes, thank you very much. Excuse me. My name is Dr. Kazabran. I'm from Moscow. And my question is basically, as we understand, your geothermal sources of energy is just about 1% of, the last time I checked, of the energy sources in Russia. And what is the current stage that it is at the moment, and what has been done to improve the steady growth of this source of energy in Russia? Because as I found, what I got to understand is that it's more abundant in the Caucasus regions and I think the Kamchatka regions of Russia. So how have they tried to popularize this in more, in the much more, in other republics that are much more in need of this energy source?
Thank you. As I understand you, the main barriers for improving geothermal energy in Russia is related to our dependence on oil and gas. We believe that we should develop these two positions because we have lots of resources for our national consumption and for export. And Russia, for the past times, does not believe in big potential for development of geothermal energy.
Dear Anastasia, thank you. And I think our conference wait for the next presentation.
So thank you, Anastasia, and we kindly ask to Mrs. Marina Vlasova to make a presentation. And Mrs. Petrova, Aigul, we ask you to be prepared for the next report.
Good afternoon, dear colleagues. Good morning. To be precise, I would like to talk about the sectoral scientific and technological forecasting. My name is Marina Vlasova. I come from St. Petersburg State Electrotechnical University, LETI, Introtech. My talk will be a sort of a philosophical observation. And of course, and indeed, science is always about future. We know very well, and prognostic studies have always appealed to some novel scientific result. Traditionally, all these areas actually formulate some sort of forecast, and they join all the prognostic studies as well as the market analytics, and also research in the traditionally imported policies and economic trends. The most authoritative and global forecasting are the forecasts of the consulting agencies, as well as some single reports and forecasts of such sectoral studies, which are just focused on some particular topic. And foresight forecasting is a traditional prognosis or forecast which happens within the energy week in Russia. For example, they outline the main directions of technological policies within economy. For example, the traditional carbon, energetics, transport of the future, which will be much more ecological in the future, distributed generation, and so on. Of late, the technological development is something that determines energetics as an industry. So we also should rely here on our industrial partners as well as universities. And all these should facilitate technological development, which requires prognostic activity, as well as attraction of great number of industrial leaders, which previously were not part of this analysis and forecasting the trends. The basis of this research is analyzing reports devoted to the current policies and prospects of energetics development, both in Russia and abroad. Also, there are articles within this review, which are not about energetics, but about assessment of prognostic studies, as well as the basis of technological development for several decades in the future. This study was done within several stages. Each of them discovered the basic questions of research. Answer to the first question entailed the necessity of more detailed factorial analysis that can impact the forecasting and assumptions. And also there is a question about what is the method in the basis of forecasting and whether several methods and criteria can be combined within it. The second question also lies within the realm of our interest. Of course, the scientific and technological forecasting, and not only this type of forecasting, forecasting as such is basically related to risk minimization, and also it can be based upon the future scenario of development, like in energetics, for example. This is from the past to the future forecasting, and also it can be based upon a request from the community, from the societies, some particular scientific communities, some industrial groups, and so on. Another starting point is an attempt to avoid the worst case scenario of the humankind history. Everybody knows about the risk of nuclear catastrophe, as well as the negative impact of electromagnetic irradiation, also fossil fuel depletion, starvation, and catastrophic pandemics that can result in extinction of the mankind. Subsequently, the approaches to forecasting will be different here from variant 1. These forecasts can be based upon documents of international conventions, such as the Paris Convention on Global Warming, also the climatic neutral level documents by the European Union. So the questions that can help us seek the answers, and the answers to these questions, all of them lie on the surface, on the one hand, but on the other hand, in order to adequately assess these parameters and do the forecasting, you should understand what lies within the foundation, the basement of a forecast. So the first question is what, in fact, the forecast is based upon. So the most prosperous technology, this is a question, and most probably the more publications that are devoted to the same topic, the more the technology or policy will be developed further. Or the volume of publications can also be a sign of this topic being a burning issue, being under discussion. There are alternative viewpoints, and there is a search for the core of truth. And most probably, this topic will continue developing. Also, these topics will invite more and more discussion on the part of the young scientists and young venturing companies, which in fact only heat up the risk of this technology, because the young scientists will be living in the new conditions which are being formed at the moment, because the year 2050 is not something that is far away, but you, the young, will be living exactly in what is being forecast for today. And just an interest towards the topic is not enough. We need some tools and instruments in order to construct particular assumptions. What we need to forecast properly, and how frequently we need to do the reassessment or reevaluations. And also the depth of these studies is of great importance as well. Another issue is a parallel occurrence of similar ideas in different countries and parts of the world. And Marconi-Popov, for example, effect. This is an effect that we all know very well, and also the idea of constructing or occurrence of a bank of technology that can also take into account the assessment of the previous period and experience that we have. And also we can rely on the experience of young scientists as well as the industry analytics. And the results will be difficult to forecast, but most intriguing and interesting for further discussion. If you look at factors which occur within technological and scientific forecasting, you can limit yourself to separate countries, or you can select also global context. And also it's very important to look at each of the factors from two angles. This is technology and market, but in each of these variants, we have windows of opportunity, and a leapfrogging theory is also present. To illustrate pathological development of technology, which can be forecast with certain probability, you can see a figure, a picture, which is an example of scientific and technological progress. And there are steps, 10 steps, just like storage, energy, and nuclear energetics. Here you can see that for the storage system, there were 10 steps that were forecasted, and for the nuclear energetics, there were 3 steps. But it's quite clear that the share of publications in the storage systems is much bigger. So most probably these 10 steps will be much more rapidly implemented than the 3 steps in nuclear energetics. That's why we need to pay attention to the developmental drivers, which are opinions of the professional community, experts, and also with all the due subjectivity of these opinions. Nonetheless, we cannot but speak about the popular Delphi methods, which is a basement for the foresight technology oriented for the selection of the most preferable technology and alternative developments. We know that this particular method is widely applied in the scientific and technological forecasting in different countries. For instance, Japan utilizes it quite a lot, and it's for them a traditional method of forecasting. In order to somehow make the system more sophisticated, we can use mathematical background and more formalized methods, although they can also be of subjective nature because they depend on the preferences of the researcher, what indicators to use. Luckily, this does not impact the method per se, and the higher accuracy or precision of the forecast within the monitoring system is not of drastic importance. We don't actually need the accuracy of forecasting, but the correctness of breakdown, although these are interrelated systems. Dear Marina. Also, there is a demand for this technology. It's of great importance. I will just skip a couple of slides. And indeed, we managed to detect these type of trends when analyzing forecasts. And the fourth question makes us face the unforeseen sudden result. Sometimes the result can be easily forecasted. So the results of our study is not yet arrived, because actually we're just on the way. Scientific and technological forecasting is a multimodal and very complex process, and each of the petals of this flower should be taken into account.
So maybe questions in our Zoom conference, Alexander.
We have a question in Zoom.
Какое вы видите решение представленной проблемы неопределенности методов?
When the methods are not defined. If we are speaking about indefinite methods, we are planning to analyze the applied methods. For example, the flexibility of the method in these fuzzy methods, whether we can apply it, and whether there are any indicators in the basis of this method, whether these indicators can be mutually replaceable to have cleaner and more transparent results and actually better forecasting. Yes, what are the drivers which can impact the forecasting in the area of new technology development in energetics? Thank you for the question. I have already spoken about the drivers. Superficially, the drivers can be interest lobbying of certain industrial groups and whole countries and states. You know that it can be also a demographic situation that is relevant to some particular countries, or at the global scale, also sanctions, which are applied now as an instrument of impacting certain policies and political circles. But I suppose we can name others, but these are the main three. And of course, this pandemic situation, which actually we face at the moment.
Thank you. Do you have other questions? Alexander? So thank you.
No, we have exhausted all the questions. No, it's
The next, thank you. And the next presentation is gas balance control in the regional gas transmission network with a hybrid adaptive narrow fuzzy interference system from Aigul Petrova, St. Petersburg Technical University. The presentation will be online. And please, for the next presentation, Nikolai Romanyuk will be ready. Dear Aigul, are you ready?
Can you see my presentation? Can you hear my voice?
Yes.
Thank you very much. So the theme of the presentation is...
sorry, can you please present full screen for us?
Is it okay?
Oh. You can use slideshow or screen. Try put F5 button.
Yes, I know. I have already done it. Just a moment. Is it okay now?
No.
Not yet. Strange. Because I have already done. I have put push on the F5 button.
You have two screens?
Yes.
Извините, на русском скажу. У вас случайно не два монитора?
Нет. Just a moment right now. And now?
Нет, мы видим окошко PowerPoint. Ну, если у вас, в принципе, работает переключение, я думаю, что в целом, наверное, можно приступить к демонстрации.
Okay.
So the theme of the presentation is the gas balance monitoring in the regional gas transmission network using intelligent methods. One of the problems of the gas transportation system is the gas imbalance. This is that is difference between the gas supplied and gas taken from the system during the reporting period. This imbalance arises due to the influence of many changing factors, such as parameters of gas equipment, pipeline, and environment, and so on.
You can see on the picture in this slide the gas balance control model in the gas transportation system, which consists of three main parts, which are gas distribution stations, gas metering stations, and gas reserve accounting procedure. In this case, we will talk about the third one, gas accounting procedure, which is in this slide too. According to official documentation, the gas reserve in the section of the main gas pipeline has to be calculated using those complicated formulas. When analyzing these expressions, we can see that each component takes into account several non-linear factors, which together can affect the correctness and speed of calculating. So according to some literature sources, some of the parameters were recognized even as impracticable, and some approximate formula now is used. Thus, it seems appropriate to investigate the application of new modern methods for calculating the gas reserve, in particular intelligent methods such as artificial neural networks, fuzzy logic, or their combination. In this case, we will talk about the use of adaptive hybrid neurofuzzy system and pure neural network method. To use this method and to research the application of these methods, the statistical data was used. Statistical data of gas reserve of 5 months in a regional transportation system, and you can see the graph of this data on the right part of the slide. Adaptive hybrid neurofuzzy network is a multi-layer neural network of a special structure. Information processing in a neurofuzzy network is carried out under the logic of the fuzzy system, and the parameters are set according to the rules of the neural networks network training. So advantages of both methods, fuzzy logic and neural network, are combined here. It's a hybrid model. Advantages of the fuzzy logic are clarity of presentation and simplicity of interpretation, and advantages of neural network are possibilities of constructing and learning the rules in more correct way. And the most widespread is this ANFIS, so-called adaptive hybrid neurofuzzy inference system, which is shown in this slide. To compute the parameters of the membership functions of the fuzzy system, using neural network, several methods could be used. In this article, 2 of them were considered, which are subtractive clustering methods and grid partitional method. Subtractive clustering, in subtractive clustering method, each point is considered as the center of the cluster. You can see it on the left part of the slide. And then the likelihood measure of this assumption is calculated based on the density of points in a given neighborhood, so the considered point. And further calculations are performed iteratively. In the grid partition method, membership functions of fuzzy terms are evenly distributed within the range of data variation, and knowledge base contains all possible variations of the rules. And now we can see the performance of those both methods. We can see that grid partition methods provides much more connections between neurons of the model, and it's explicable because of definition of the grid. These methods, as we have seen, it contains all possible variations of the rules. And we can see also, we can build also the surface of the model using those both methods. And we can compare the result of using this trained model to with both methods with the testing data. Blue points on this slide belong to the testing data, and red points belong to the trained model. And we can see that grid partition method provides us with more accurate results. And another method was used also, a pure artificial neural network. And in the left part, we can see the error of the model, and in the right part, we can see the result of testing, training, and validation application of the method. And in this table, all three methods considered are compared together, and we can see that artificial neural network, pure neural network, provides more accurate results, and which that's why we can assume for now that this method is more applicable to solve this problem of gas reserve calculating. In the future, to improve the quality of the gas reserve calculation, it's planned to expand the training sample, to improve the base of fuzzy rules, to build a controller based on artificial neural network, to use the real temperature of the environment in calculation, and to build a regression model based on artificial neural network too. I'm ready to answer your question.
Dear Aigul, thank you. Dear colleagues, do you have any question?
I can see the question in chat.
Okay.
У нас есть вопросы с Zoom.
We got a question from our Zoom chat.
What was considered as Bashkirian gas transportation system? Thank you for your question, Polina.
So, any other questions?
Then I have two short questions. First question, what data do you use for training, testing, and validation of your neural network?
I separate statistical data. 70% of data were used as training data, and another part was testing data.
It was open databases. Where do you get data sets?
Thank you for your question. It's all statistical data of the enterprise.
Okay, thank you. And the next question about the metrics for your study. What metrics do you use to estimate the quality of your solution?
So far, I have used the learning and test error and the number of factors if to talk about fuzzy hybrid methods.
Thank you. Any questions? As I see, we don't have questions. And then the next presentation.
Please, greetings for Mrs. Petrova Aigul. And the next presentation will be done by Nikolai Romanyuk, St. Petersburg Polytechnic University. The report, Expression of Resource-Based Technique on Feasibility Study for the Use of Plasma Gasification for Residential Complexes. And please, Mr. Anatoly Fedash and Kirill Makarov from Gubkin State University, your presentation will be next. Please be ready.
Здравствуйте, уважаемые участники конференции. Я Роман.
Good morning, dear participants of the conference. I represent St. Petersburg Polytechnical University. I am going to speak about the expansion of the resource base and technique of the plasma gasification for residential complexes. So I would like to say that this topic is actual because of the ecological issues and waste of different origin, including energetic and industrial. In order to use this potential, we need certain grounding of feasibility study in the areas where the waste is dumped. We are faced with the lack of studies, as the serious technical and economical feasibility studies are usually done for larger enterprises of waste recycling. In the residential complexes, we don't have the studies usually, and that is why, having no information in place, all this waste is usually transported to some other area, like outside the city border. And subsequently, we need some sort of recycling techniques that can be used in the vicinity of residential complexes. For example, it can be used not only in Russia, but in Belarus in the conditions of integration between two countries. The dynamics of such residential waste or community waste in Russia and Belarus, you can see here data from the Belarus and Russian statistic agencies. Also, these slides show the indicators of waste per capita. In Belarus, it's 3.5 million tons, which is equivalent of an energy of 84.5% of energy balance of the country. In Russia, the generation of similar parameters in 2019 accounted for over 400 million tons, which is an equivalent of quite high, over 90% of the energy balance of the country. Plasma gasification can definitely be very positive in the balance of generating capacities in Belarus more than in Russia, because it will also improve the energy security and safety, as well as the storage system development, which is an important issue of integration between the two countries. Another importance is the coefficient of waste recycling. In the European Union, it grows steadily, and in Belarus, it's 2.5%, which is also visible from this slide. Research methods and stages, 3 stages: development of the technology selection criteria and selection based on the proposed criteria. Also, feasibility study and risk assessment of the proposed technology. As a university campus can be taken as an example, and conclusion on the technology applied. We have chose the criteria which are present here on the slides, and also we selected a particular system of plasma gasification. We needed to find a technology which can be used for the residential complex. It must be safe and feasible economically speaking. Also, it must comply with all the requirements, norms, and standards for such technological object which is located in the residential area. You can see this ecology and location and an example of implementing such technology. In order to study, we looked at a residential complex in St. Petersburg Polytechnical University, and we calculated and proposed the method, and also provided feasibility study results of the waste recycling and energy generation by means of plasma gasification. Feasibility is assessed according to the economized finance, and the results of calculation are provided at this slide. We also took into account all the type of waste that is recycled, and also economy in waste disposal, in technical maintenance of waste servicing, and also there can be unforeseen expenditure on just households chores. And all these indicators are taken into account in this particular equation. As you can see from this slide, when we approximate the level of 18 rubles, then it will not break even. So in our case, we needed to apply certain characteristics of the dependence of the payback period. So also we should take into account the very high depreciation rates, which again will result in particular parameters of economic feasibility. Also, we additionally assessed risks, for example, changes within the annual expenditure, and it will not distort the project parameters. The results of implementation, first of all, this is absence of different transportation and disposal at polygons or landfills. Also, we partially can compensate the household needs, and there is a payback on particular disposal of plastic and glass, and also the energy resource potential is broadened. For this project, it can be characterized like this. The figures are on the slide. So this is the end of my talk. Thank you for your attention.
Thank you. Do you have any questions? Yes, please.
Have you looked at the sorting station opportunities where the waste is located? I will show you on the slide. Can I flick the slides back? You can see here the distance between the areas where people live is approximately 100 meters. If it is located under the ground, if it is on land, then the distance will be 200 meters. It's for sorting and recycling in one. Thank you for the question. Thank you.
Dear colleagues, any questions? As I understand, we have questions in Zoom.
Yes, hello. We have two questions to the speaker. The first question is, at what expense do you see, or why do you see big efficacy of small enterprises of waste recycling, if compared to the large enterprises? Because the bigger ones are more economically effective. Yes, they are effective because of the scale and dimension. So the technical calculation is mainly done for them. But we do not take into account the small generation, because you save cost. The transportation cost actually is not paid. And this logistics indeed helps us to save money. There will be no additional CO2 emissions, and there will be no huge polygons or landfills. So generally speaking, there are a lot of benefits in the project that I'm discussing. And so indeed, it needs to be looked into. There is no scale effect, but there are positive effects for sure. After waste recycling, there are some waste which cannot be recycled, and they are most dangerous, most hazardous. So most probably there will be a temptation to get rid of those in a small enterprise. Subsequently, ecological risks will go up. How are you going to avoid this situation? The plasma gasification, in fact, uses a temperature of 300 degrees. And the peculiar feature of this technology is that as a result, we have a substance that can be used in road construction. And even this is reflected in economical feasibility study. And generally speaking, all the negative impacts and risks have been assessed, and they are here. this slag or clinker is something that our technology receives, and the ecological, it is ecological friendly because the emissions are at a minimum. How can we avoid the risk of non-recycled waste? The risk, can you repeat the question or clarify it? I don't get it. How can you avoid the risk of non-recycled waste? This is the question. In this situation, we fully recycle. There is no risk. We have already done away with it. Thank you. Yes, it's quite difficult to understand what they meant by this question. Thank you very much. As far as I understand, there are no more questions to the speaker.
Thank you. Next presentation is from Anatoly Fedash from the Gubkin Russian State University of Oil and Gas, renewable energy sources. And the presentation will be online. And for Maksim Lisitsa, please, you should be ready for the next presentation. Yes, please.
I know that Kirill Makarov will also join Mr. Fedash, so we are ready to listen to your presentation.
Yes, we'll start our screen sharing. So we have three actual speakers. Good day.
Dear colleagues, are you ready? Okay.
Yes, we're ready. Second.
Сейчас вот перезайти надо, чтобы включить демонстрацию. Там проблемы какие-то в Zoom начались.
There are some Zoom issues, so we need to re-enter into Zoom. So to switch on the screen sharing mode. Sorry for the delay. Can you see my screen? Yes.
Please remember about our time is just 7 minutes.
Today we would like to talk about renewable energy sources. So it's energy produced by of the energy sources from life products and of plant or animal biocenosis. So these resources are, so to say, renewable or can restore or non-exhaustible. Let's talk about alternative energy sources in Russia. We have solar energy, wind power, water energy, geothermal energy, and bioenergetics. Solar energy. Sun is the main source of energy on our planet. Since about 173 petawatts of solar energy comes to our planet, which is 10,000 times above all the all Earth's energy needs. And the potential of alternative energy is about 2,000 billion tons of conditional fuel, and the greatest prospects with that regard belong to Crimea, Caucasus, Stavropol, and the Far East. New solar stations functions in more than 25 regions, and with regard to the power, Orskaya, Soletskaya, Samara, Burybaevskaya, Bogulchanskaya stations tend to be the first one. Let's talk about the wind power. Wind power is one of the moving forces, is a long-term tradition. We use it for many generations. Wind energy is one of the most rapidly growing renewable energy field. And during the last data, we see that almost 75 times increase of wind power production from 7.5 gigawatts in 1970 to about 564 gigawatts by 2018. At the moment, Russia quite weakly uses such resources of wind power, and the largest wind power in Russian Federation was launched in 2020 in Stavropol region, and in the last year they produced less than 1% of the total consumed energy. Then water energy. Since the end of the 19th century, water energy is used quite actively in Russia, and we've got lots of hydroelectric power plants, which are the largest: Tsayan-Shushinskaya, Krasnoyarskaya, Bratskaya, Ustylimskaya, Bogushanskaya, Volжskaya, Zhigulevskaya, Boreyskaya, Saratovskaya, and Cheboksarskaya power plants. And the largest hydroelectric power station is Zagorskaya hydroelectric power plant. It is even present out among 10 largest power plants globally. Geothermal energy uses the Earth's heat to produce electricity. Temperature of the subsurface hits the upper layers of the Earth and underground reservoirs. Geothermal energy of the soil is extracted using small wells. It doesn't require large investments. It's especially effective in those regions where fuel sources are located close to the surface and crust of the Earth. In seismically active regions in the Russian Federation are in the Far East, in the Northern Caucasus, and development of geothermal power plants, of course, is limited specific territories in the Russian Federation. You cannot use in Urals and the Altai, and currently the Earth's heat uses to heat residential buildings, agricultural buildings, greenhouses. And main geothermal power plants are Paushchetskaya, Verkhnya Mutnovskaya experimental industrial station, Mutnovskaya, Oshanskaya, and Mendeleevskaya. Then bioenergetics. Bioenergetics is universal. Heat, electricity, and fuel can be produced from solid, liquid, and gaseous biomass. At the same time, we could use as renewable raw material waste of plant and animal origin. Currently, Russia is one of the global leaders on production of biofuel of different types. Mostly we produce and export solid fuels, but currently they use biogas power plants, which with different capacity, which could produce biological and heat energy, and they produce it for devices for sufficient use per one, so to say, household. Bioenergetics is a rapidly developing field, along with other alternative methods for energy production. Which intermediate conclusions we can make on this part? The share of renewable energy sources in Russia is very small, less than 1%. There are immediate plans, and if they are implemented, then this share will reach 1 to 3% of the total generation. Existing measures to support renewable energy facilities guarantee a return on investments with an income rate of 12 to 14% annually for up to 15 years. More than half of wholesale selections of the renewable energy projects were won by company state participation, but the shares, most of them are not traded on the stock exchange. Renewable energy companies are traded on the stock exchange are not yet represented on the Russian energy market. Then we'll talk about strengths and weaknesses of renewable energy sources. Start with strengths. We decided to take specific examples to understand this better. The prices for solar energy, they win records. In India, they did a contest for solar energy prices. The record price was reached 2.78 of Indian rupees. It's about 0.036 of US dollar per kilowatt hour. So also wind power surpassed gas and electricity generation in the UK for the first time in Q1 2020. So in this quarter, renewable energy sources started to be the main generation source, far ahead of the generators using fossil fuel. So they produced 35.5 TWh per hour of electricity. For the comparison, the first quarter 2019, the production of renewable energy amounted to 27.4, and more than 1/3 of electricity in the world comes from renewable sources, a new record. It's a new record parameter as and the International Renewable Energy talk about. From the period from the 2018-20, the production of such power stations decreased, but still the share of renewable energy sources increased, and about 2 or 3 objects of renewable energy production are built in the regions of where they considerably affect natural, so to say, nature areas for natural several animals. So let's talk about the development, the use of renewable energy sources in Russia. So as to current assessment, technical resources of renewable energy in Russia, which where we see highest potential for the wind energy, solar energy, is at least 2.5 billion tons per year, which is more than 4 times above the use of all fuel energy sources in Russia. Currently, this potential in the Russian Federation is about 270 million tons, included by types of sources. Solar energy about 5 million, wind energy 10 million, and so heat about 115 million tons. This potential, the Russian Federation provides good perspectives to resolve various problems. On the other hand, renewable energy sources have higher costs versus energy generated by the large traditional power plants, conventional power plants, but still the Russian Federation are great lands. Then due to environmental, social, and economic concerns, it's quite feasible to produce energy using, so to say, renewable energy sources. What are state support measures? The increase of the energy production to 2.5% with renewable energy sources due increase of the power of generators function on solar, wind, or water energy, not considering conventional hydro plants. The support of this renewable energy sources in Russia has several tasks. They have federal and regional levels where they have sort of say support mechanism. For instance, there could be support for the supply of the capacity facilities to the wholesale market at a price in accordance with the procedures, and also they have special stimuli supporting production and use of basic and auxiliary generating equipment. Also, there is also a mechanism to sell energy to grid organizations to compensate losses of generating facilities connected to the grid. The key parameter for support mechanism is a contest selection of projects. The annual competitive selection of renewable energy projects for 4 years ahead. Selection of projects according to the criteria of the lowest capital cost and the requirement to comply with the degree of localizations of equipment. That's it.
Audience hall. Yes, we have one question. Please give a microphone.
Thank you very much. I have 2 questions. But I would like to quickly ask this question. What exactly was the purpose of the presentation? What exactly is the aim, the objective? Because I didn't quite get that. Could someone please?
Anatoly, Kirill, Maria, please, what is the purpose?
The main purpose was to show the importance of development of renewable energy sources, and they, though we say lots of good words about them, they still have some shortcomings which we work on. So they produce lots of energy but on the other hand, they have lots of, so to say, negative sides.
What can you say about the carbon footprint and the land footprint of these sources of energy? Because from what I understand, these sources of energy require at least 450 more land mass to execute. For example, the solar farms, the wind farms, and the water sources that you use to maybe endangered species of fish. So what exactly could be done to reduce the risk? And have you considered those methods? Thank you.
Thank you.
Specifically for solar panels, I can say that to feed the whole world with solar panels, it's sufficient to install panels at the square as the area of the average Russian city. Talking about the carbon footprint of wind power stations, it is there because the problem is that they cannot be, so to say, properly recycled, and they just, so to say, buried. And they made, for instance, but in Finland, they made eco-friendly, for instance, parts.
Question exactly is, we understand that you could make a farm the size of a village, right? But why do you need so much space to create energy that could be the same amount of energy that could be done by just a small nuclear power plant somewhere?
А можно поконкретнее перевод? Не очень было понятно.
Maybe you will repeat your question in Russian.
Reformulate your questions, please.
Да, понятно, конечно, что мы можем.
So it's clear that we can, in some space, create that generates solar powers. Why should we use that much space, which if we can generate the same number of amount of energy using one nuclear power station?
So you see the question is connected with space replacement, because if we use CV panels, we have to use a big space, yeah. And if we are going to use small generators, so the space will be used less. And how to explain this need of the space?
As I think our colleague meant any trade-off between space and safety. And please explain how you understand this situation.
Well, regretfully, at the moment, not all nuclear power stations satisfy the requirements, for instance, of the Paris Convention, which protects us from, for instance, damaging of the ozone layer. So we should look for this trade-off, finding finding the, so to say, happy medium between the traditional energy sources and renewable power sources. I have a question about environmentally friendly stations. As you said, nuclear power stations could use the technology of so-called closed nuclear cycle, which minimizes amount of nuclear waste. So could you explain why nuclear stations do not satisfy Paris Convention requirements? Well, not all of them, of course, I don't say that. But if you wanted to follow the trends of the 21st century, we need to look for the happy medium to use alternative energy sources, because the global market actually is focused on them. And in Russia, in particular, there are such regions, as I said, that there are some where it makes sense to use renewable power sources, use such renewable power sources generators, and develop this type of alternative energy.
Yes.
Question is the following: which type of renewable power sources, actually, which of them could be considered as a future for energy production in Russia? Well, from my point of view, it should be geothermal energy, just because wind power here is not relevant because it's too expensive. The solar panels, they could be installed only at some climatic zones, climatic areas, with some only some specific, so to say, lands. And so I think it should be geothermal energy. And then one more question to catch up, and the potential of hydro power plants. Is there no more potential for them? What do you think? No, not really. But what do you think about perspectives of water energy? What do you think about that, about these perspectives? Well, I think they're quite serious because our stations are considered at one of the largest at the global level. But
and now we are going to invite Mr. Maksim Lisitsa from Electrotechnical University LIT with his report Circular Economy as an Alternative to Green Economy. And we kindly ask to be ready Mr. Roman Sargorodtsov for the next presentation. So, dear colleagues, please remember about our timing, just 7 minutes for presentation.
Добрый день, участники.
Good morning, dear colleagues and participants of the conference and our Zoom audience. I'm very happy to welcome all of you. And I would like to start my talk, which is devoted to circular economy as an alternative to green economy. As a matter of fact, there are two issues which are relevant to two economies. First of all, alternative, whether they are alternative to one another or they're synergic and complementary to one another. The answer to this question is both ways, because very frequently they're seen as complementary to one another. And also there is opinion of different experts that consider green economy to be part of circular and vice versa. But our vision over it is the following. First of all, it's important to see how they are structured in terms of the paradigm. The green economy is not different from a traditional economy because it is quite linear in its structure. But the circular economy utilizes completely different approach, where the closed loop approach is used. For example, green economy or linear model is structured in the following way. So you have consumed something, you have waste, and you throw it away. But in circular economy, it's different. You recycle, use, and recycle, and reuse, and so on. So in this particular situation, they are alternative to one another. When it comes to the concept of green economy and its content, it's rather sophisticated. And it is not existent by itself, because you can pay attention to this slide that shows very well the fusion of several spheres. These are the sphere of economic development, environment, responsibility for the environment, and social or societal development, and technical and scientific progress. If you look at all this, then the sustainable development cannot be counted on, because the more restrictions and limitations we have, the worse will be the final outcome. This is just usual mathematical logics. When it comes to the circular economy, then we have quite an abstract model, because generally speaking, we need to understand what part of the cycle we are in, for example, St. Petersburg or Russia or some other location, whatever you name. Everybody wants to be somewhere in the area of design or development or production, at least, like China. But nobody actually wants to be in the final stage where the waste recycling happens and where emissions happen. The idea behind it is that the circular economy is not an absolutely closed loop model. There will be emissions anyway, and it's very important to overcome some utmosts and understand what to do with the emissions and waste. Further, I have already explained to you that there is a conflict between two economies, explaining it to you that the linear economy per se envisages certain waste, and the circular economy must be resolving this issue, but there are different options of integrating both schemes or systems into one another. So when one economy is part of the other, and here we managed to avoid this full compatibility, they can be part of one another, but this particular viewpoint will be even more complex if you come to fuse these two economies. Then in the long run, or eventually, we won't receive any synergy between them. When 1 + 1 equals 3, sometimes it's 1 + 1 equals 0. So we won't be capable of resolving the issue at all. We would like to say that there are major issues related to green economy. We actually want to say that the more additives there are, the lower will be the quality. In fact, I was very happy to hear from the previous speakers who had very acute discussion, actually quite sharp and opinions, and there are no more comments actually, because I've already told you that the more impurities, the lower is the sample. So subsequently, with these renewable energy sources, you can transfer them to, for example, water resource management, and also changing the climate within these territories. All these problems are the ones that we face. When it comes to green building, you can imagine that we live in cities, and all these materials, in fact, this building construction materials, at a certain point, the buildings will ruin, and what should be done with this? If you take into account that these buildings which are located here, there will be something to be done with them when they are disposed, when there is active stage of circular economy, like in 50 or 100 years, for example. These are quite far fetched, of course, but nonetheless, even today, we would like to speak about what is going to happen in the area of transformation within the circular economy. Anyway, all of us are humans, and we understand that the priority is economic growth. This is going to stay with us forever. Further, economic growth rules out the negative impact over the environment, but it doesn't always happen like this. And you also saw the functioning of circular economy. Most probably it will be organized as clusters, when the resources undergo certain cycles, and then they are turned into waste, which in its turn becomes a resource for newer components of circular economy. This is a two-component model. They can be several loops. And the final thing that I want to say is that, generally speaking, both economies, just like paradigms, they can coexist, and we should treat them adequately. That the green economy actually makes the problems more visible, and circular economy is more about a tool how to solve and resolve these issues. And I hope that we will manage actually to resolve all the issues at their maximum.
Thank you.
Thank you.
Maksim, any questions?
Maybe questions in the Zoom chat?
Да, у нас.
Yes, indeed, we have questions in Zoom chat. It's a question in English, but I will read it in Russian. What do you think such policy as right for repair, will it happen? Will it just help the circular economy, and what can we do to make the world economy more sort of closed? I did not hear one word there. Can you kindly read it out again? Yes, I will repeat. What do you think such policy as right for repair, can it help the circular economy? And out of your opinion, what else can be done to make the world economy more circular? Well, thank you very much. Whether it will help or not, the question is about trying it out. Most important here are the details. And generally speaking, when we shift to a circular economy, we would like to say that this would be a new technological revolution, but I suppose it's not the time when we can name it such. The approach to design of everything that we consume will be completely different. We shall immediately think about what to do and how to do it, and how to use it after it is already used and must be disposed. The second situation, how to make an economy more circular. The thing is that if you look at the problem as clusters, the more clusters there are, the more closed or circular the economy will be, because the appearing waste becomes a resource, raw material for some other cluster. This is how it's going to work. The question about minimizing the disposal is out there. Let's give an example from the nuclear energy. For example, the nuclear waste, what should it be done? Should be done with it? Should it be buried, or it should be used in defense, or newer nuclear fuel? Everything at the moment is recycled into new nuclear fuel. So such type of recycling, in fact, is questioning the prospects of thermonuclear development. It has just been born, and there is already a disruption of the model, as the cost of fuel is approximately 5% there, and all the other is everything that's happening around it. The more elements we have, the closer or more circular it becomes. And we have two more questions. Circular economy, continuing the life cycle of a product. Is it contradictory to it is contradictory to contemporary conspicuous consumption culture? How can we resolve this contradiction? This is a good question, indeed. I suppose that this contradiction per se will be resolved because the recycling is not free of charge. We recycle something let's imagine there is a great deal of plastic, which is inside the water, and it gets into any microorganisms and fishes. And if we actually recycle it and get it into cement or some, for example, some construction materials, then all these can be sold, and you can reuse all these things. So in these cycles, I don't see any contradictions. And by the way, that's what is happening at the moment. We can see new construction materials like arbolite, for example, and it's a mixture of wood and cement. Thank you very much. And we have 2 more questions, but the time is sufficient only for one. How can we implement circular economy in Russia, and what are the means of doing so? So here I will actually respond to it as a classical specialist in economics, excuse me. So as a politician and as an economist, first of all, we need political will. If we force something, we can force, of course. There must be a person who has political will. The community must vote for this person, must elect him, and he must actually make us promote circular economy. This is from the political viewpoint. From the economical viewpoint, we have natural levels. I suppose that the answer will be the following. Everything must be easily available for use. So the technology is existent and they become cheaper. And this will result in mass application, in mass use because of the price. Maybe I have responded to the question. Thank you.
Thank you for your presentation. Next presentation will be from Roman Tsarigorodtsev. He present the report, comparative analysis of LNG and renewable energy sources. The presentation will be online. Roman presents Gazprom company. Roman, is you ready?
Да, добрый день. Надеюсь, меня хорошо слышно и видно.
Yes, good afternoon.
Asked to be prepared for the next presentation, Ms. Gorina Olga from St. Petersburg Mining University with the report Energy Efficiency of Technology on Hydrogen. So, Roman, it's your turn now.
Еще раз добрый день, уважаемые организаторы, гости.
Good day once again, the organizers, guests, and participants. And for me, it's a great honor to be here with you with this presentation. It's the first time. So this work was to assess the leading position of LNG using comparative analysis with renewable energy sources as a competitive energy industries.
Yes.
А сейчас?
Yes, thank you.
Да, а сейчас, коллеги, как меня видно?
Now you can see my presentation, but it's not in full screen mode.
Так, вот так, да?
Display.
Начну. Сначала данная работа заключается в
The work is determined leading position of liquid natural gas by comparative analysis with renewable energy sources as competing energy industries with development perspectives up to 2035. Hypothesizing an unknown energy source capable of replacing traditional, conventional energy sources. Recent years, we've observed how energy based on renewable sources is confidently crowding the traditional one. Every year, hundreds of gigawatts of renewable energy stations built around the world. For 5 years in a row, green generation has been producing, exceeding those producing coal, gas, and nuclear stations. In global investments in RES exceeds $100 billion. Due to this active growth, there is a question: will this energy replace traditional one? How long will it take? And is renewable energy more environmentally friendly and cost-effective than LNG? These questions indicate this topic is quite relevant in current realities. So, due to the studies, we plan to structure main positions, statements on rugged energy and RES. We use such criteria as a possibility for energy storage, environmentally friendly production, use and disposal of research items, state support investments in RES and LNG. Overview of the companies working in the field of RES and LNG. Determination of strategy for LNG industry development is the country which is a giant with gas reserves. Consideration of outer spaces. Outer space is a potential source of obtaining the latest century with the Romanyuk International Space Exploration Program for 2021. Though interested countries actively fund and use RES, they have still several problems: production, use, storage, and environmental friendliness with the environment. On the other hand, increasing LNG share could really compete with RES. Studies show that LNG is an effective solution to solve to be present as a backup fuel.
Maybe you have two screens? Is it the issue?
Роман, я вам сейчас остановлю демонстрацию экрана. Запустите заново.
I will stop screen sharing. Please choose select a screen. So have screen share mode and choose the screen.
Демонстрация экрана у меня выражена зеленым.
So press this button, screen share, and choose the screen option.
Нажимаю, у меня ссылочек никаких не выходит почему-то.
Press it, don't see any links. Just press screen share, choose screen, and then press share. We will see your screen and your presentation will be there.
We are so sorry for technical issues.
Да, sorry. Так. Коллеги, у меня все так же. Поделиться не имею возможности.
Ну вот, то есть нажмите вот демонстрация экрана, вот кликните просто на нее, которая светится зеленым цветом.
Да.
Появляется ли у вас окошко с выбором экрана?
Нет, окошко не появляется, к сожалению.
Okay, maybe you will continue to present your speech because we've already saw the whole list of your slides. And as I understood, you were in the final part of your report.
Да, все верно. Это уже практически окончание.
That's right. It was almost the end of my talk, so if you're quite right.
So we are ready to listen to you without the slides. Please give a support for our presentation.
Исследования показали, что СПГ
The studies showed that LNG an effective solution for the problem of an backup fuel. LNG is especially important for industries where the main fuel is a natural gas, which makes it possible to avoid cessation of production when doing start services, when you start services, or when you do some repairing. When you think about high energy effectiveness, safety, and other properties of this fuel, the storage of LNG is also quite safe, compact, and environmental friendly. So we think that LNG has really a short-term good prognosis, but in the long-term prognosis, RAS could be a great competitor. But dear colleagues, it's too early to set the final point which of the energy sources is, so to say, more, which of the resources is better. You should remember that there are, we talk about outer space, and there are researchers on various asteroids, moon, and in outer space. So maybe there will be a new potential novel element will be discovered, which will become an absolute leader in that field. And thank you for your attention. I'm ready to answer your questions.
I hope you can hear it. And any questions from audience? Okay, please, Alexander Parin, can you tell us about the questions? I'm sorry, we have questions from audience, please.
Благодарю. У меня вопрос.
Thanks a lot. I have the following question. In Russia, we built stations to produce LNG. And at the moment, as far as I know, there have been signed agreements or contracts to supply to China. So what's going on with those contracts? Is there any supply to China, or are there any delays with that? Have you heard about that? Anything? Thanks a lot for your question. Well, about China, this question is still open for me with regard to LNG supplies there, so LNG deliveries there. So I will study this issue soon, and I'll be able to answer you, if you wish, by email.
All the questions, we collect all the contacts. So in case you have an opportunity, you have a wish to discuss some topics more in detail, so do not hesitate to contact us for it. So thank you. And we have one more question from the audience. Am I right? Yeah. So can we show our person who give a question?
Okay. The question is, practically has to do with the statistics, because if you're trying to compare, because we were not able to see a lot of the slides, so there was nothing we could see to give us a visual imagination of what was going on. So if your aim is to improve something, what could you say about the immense amount of energy required in transporting liquefied natural gas, which also leads to the emission of greenhouse gases? What have you done to control this process, and what methods do we have? What statistics do we have to support the claims that we could do something better than what is being done now? And do we have other models from other countries that are being used right now that we could use to compare the current methods to?
Thanks a lot for your great question. It's a good question. Well, talking about the transplantation and LNG for the future, I would like to look at the long-term perspective and use LNG as a source to produce pure hydrogen, which then will bring CO2 trace to zero. Thus, it will help us to combat climate warming. And we have a question from the chat. We have a question to that. Oh, you think that green energy, I mean, wind, solar, water energy, is it truly green? But what about its effects on the environment when you produce and use equipment for such energy production? Thank you. Well, it's a good question. But again, I'll try to answer it. Your question via email, if I may. So,
and we will collect it and give it to Roman for answering your question. So, thank you too much. And we are going to listen to the presentation of Ms. Gorina from St. Petersburg Mining University with the report Energy Efficiency Technology on Hydrogen. And also we kindly ask to be prepared for the next presentation, Ms. Tatiana Meshcheryakova with the report Developing Green Building Standards in Global ESG Transformation. Thank you. So, by the way, I will remember you about our schedule and our time and regulation, just 7 minutes. You see that this discussion was fruitful and discussion was full of details. So we ask some of our presentations to postpone their presentations on the second part of our section. So just one presentation from our section to the second part. So, are you ready? Please.
Добрый день. Меня зовут Горина Ольга. Я представляю...
My name is Olga Gorina, and I represent the St. Petersburg Gorny Institute. And I'm going to speak about energy mining university, where I'm going to speak about energy efficacy of hydrogen technologies on thermal power plants. At the moment, this is one of the rapidly developing branches of energy industry, and the current interest towards hydrogen can be explained by different reasons. First of all, there are zero CO2 emissions, just steam. Also, it allows us to integrate renewable energy sources within overall energy system. But on the other hand, it has highest heating value that can be burned in the existent energy systems. What does our foreign colleagues show us, such as Siemens, Kawasaki Industries, and others? We have hundreds of different hydrogen turbines, and the overall output is over 450 terawatt hours. For my country, when the major part belongs to the steam turbines and subsequently steam boilers, it will be much more interesting to look into an opportunity of using hydrogen in the energy boilers. This is not studied at the moment vigorously, and we're trying to change this. As an object of our research, we decided to look at the steam boiler E42014-565, which is installed in Urengoy, Uzhgorod. If we change the natural gas and elevate the share of hydrogen, we receive the following results. So hydrogen blending effect on heating value. Hydrogen has very good thermal value, 3 times as high as natural gas, and I've already talked about it, but the lower density, it's 9 nanogram per cubical meter. Subsequently, if you introduce it into the fuel, then its thermal value will go down and the mass will go up, or weight will go up. This can be misinterpreted or result in misinterpretation of consequences, because usually we calculate the weight or volume of fuel we introduce into the heater of a boiler. So that is why we need other calculation logics. And quite logically, if the mass heating grows, then the volume thermal capacity goes down, which can result in an idea that we're going to have higher capacity in hydrogen fuel. But to burn hydrogen, we need smaller amount of air. Subsequently, the overall amount of gas mixture in the boiler, this is upper part of the slide, will not be significantly changed. The major advantage of hydrogen is a reduction of CO2 emissions. And as you can see from this slide on the left, if we have 50% hydrogen, the CO2 emissions will be reduced by 3.5 fold. And also we should speak about nitrogen oxide formation, which is also related to hydrogen combustion, but we can come back to it a bit later. The main barrier that at the moment stops hydrogen technology is, of course, a very high cost of hydrogen. Hydrogen cannot be found naturally in the ecosystem. It should be electrolyzed from water, or it can be a result of fossil fuel processing. At the moment, the steam methane conversion is the easiest way to get hydrogen. So we get a mixture and we receive hydrogen and the so-called biogas. This is the technology that is easily reproduced in the thermal power plants when we have both types of resources. And the hydrogen, if it approximates to the consumer, we can also reduce here the storage and transportation costs. And also the hydrogen can be seen as energy accumulator. For example, in the night damping period, we can use the steam in the boilers in order to produce hydrogen, which can be sold to the outside customers or burnt in the boilers at the period of peak load. At the moment, we are calculating this idea, my first experience of presenting this project to you. So I will be happy to get the feedback.
Thank you. So any questions from the audience? Yes, we have one question. Dear volunteer, please give a microphone. And Alexander, by the way, do we have also a question in Zoom? Okay.
Yes, we have a question.
The first question is from the audience and then from the Zoom. Thank you.
This is an interesting presentation, and I have a question about your final thought about the production of hydrogen, which is associated with certain difficulties that you have mentioned. How can we how can these problems be combined with Professor Larin's idea that there is hydrogen in the land, and if you actually collect it from the soil, you can resolve this issue at certain points? You are speaking about mining up to the core of the... No, I'm speaking about his theory or hypothesis by Professor Larin. This is the theory that is existent for many years. He spoke about the hydrogen core of the Earth, and the pure hydrogen comes up. So the water that accumulates on the surface is the so-called oxidated hydrogen. you are speaking about the fact that hydrogen is not cannot be found in the natural condition. Yes, but we cannot collect it industrially speaking or commercially speaking. That's the question. If this causes just deeper discussion, then I suppose we can continue speaking. But can you answer this question for now? No, I cannot. Can I have this name? Professor Larin. Thank you.
Thank you too much for the question. And Alexander, please. Your question.
What are your further plans for the study if you speak about emission or increased emission of hydrogen oxide in combustion? Indeed, it really happens, and CO2 emissions. Oh, excuse me. NOx emissions can be higher. We have already studied the experience of our foreign colleagues who depressed these emissions. They managed to curb them at a power plant in Fusino, AL project by the Japanese. They actually looked into this matter already. I suppose we shall scrutinize their experience and understand whether it is applicable for Russia.
Any questions?
We don't have any more questions. I have a question to you. I represent more sort of practical side. You are speaking about this boiler, 450. It consumes approximately 35 cubical meters of gas, but the power plant of a small, for example, a city will have 3 boilers of this sort with a maximum 130 cubical meters of gas. So this hydrogen technology, they envisage, as far as I understand, additional complex or a station for hydrogen. Have you looked into this territory? Have you looked into this, how big the complex is going to be? Well, indeed, it's going to be, it's going to depend on the amount of hydrogen that we shall need. I don't know how much additional steam we will need and we will have during the peak-off periods. I will actually take down your idea because, you know, your feedback or your project, it's not full transfer to the hydrogen of a station. No, of course not for now at least. And another question or a comment, have you evaluated in Tut how many there will be a ton of conditional fuel per calorie? No, we haven't done this calculation. Thank you very much. I have the following question to you. The water steam is lighter than the air, so it's a greenhouse gas, just like CO2. So if in CO2 we have a chance to transfer it into carbon, pure carbon, and oxygen, what happens with the steam? So first of all, how do you get the hydrogen from atmosphere or from water? From the ambient air? No, we receive it from the mixture of natural gas and steam. And so in the atmosphere, you have emissions of steam, which is greenhouse gas. What do we do with it? How do you resolve this issue? Whether we consider steam as a greenhouse gas, which results in global warming. This is an interesting question. I never looked at it. We are trying to combat CO2 emissions, and this is what we are going to do.
For such fruitful presentation.
Thank you. And the next presentation will be from Tatiana Meshcheryakova, National Research University MGSU, developing green building standards in global ESG transformation. Tatiana, is you ready?
Yes, we can see your presentation. Please show.
Добрый день. And the last report in this session will be from Grigory Lopatenko. Please, will be ready. Sorry, you can continue.
Organizing committee, dear participants, thank you for the great opportunity to participate in the conference. My topic is development of green standards for building in the global ESG transformation settings. Prior to talk about my study results, I would like to say that I represent a bit different part of the audience from the other side, so to say, of the barricade, if I may say so. So I'm not doing all the studies and working in the university, but also one of the developers of the national green standards. So it's very good to have this opportunity to consider some problems, some issues, and use in the practical settings. And of course, there are some specifics related to green standards. So Tatiana, could you please check the switching slide? Is it you with your slides switching? So does it change? No, not so grateful. Please stop. Just we should discuss it technically. Please stop the screen sharing and choose again your screen with the choose your screen with the presentation where the presentation is open. Yes, yes. So try to switch to the next slide. Yes, now it works. Yes, thank you. Well, I will continue. So talking about the green standards, well, there are some specifics industry-wise when we talk about the building. The summer we developed first draft standards on funding for green with green standards, and in the next fall we have the whole cluster for green standards to be issued. Would like to talk about the results and tell you about the trends, which are quite clear and everybody, I think, heard about them. So what we're starting from, what we're going to, talking about the international practice in December 2019, the European Union approved quite large set of documents declaring on the climate neutral strategy by 2050, with intermediate points like decrease of the emissions by 2030 and considerable increase in use of REs about by 40%, and in power production as to the forecasts we should reach levels of 65%. Along with the European Union, there are practical activities ongoing in Asia, North America, and China. In China is declared in September 2020 the foresight on carbon neutrality. As of 1st of February, the country introduced a national system for trade in the national emission trading system. Then Japan declared carbon neutral announcement, they made carbon neutral announcement. Talking about Russia, because this first step was done in 2019 in October, when we also signed this Paris Agreement, and finally in November 2021, The first Russian foresight on carbon neutrality by 2060 was defined in the national strategy of social economic development with a low greenhouse gas emissions. This strategy determines intermediate results because it was developed until 2050. Talking about the building industry, why it is extremely relevant. First of all, if we talk about global statistics, in the whole world, the building process takes about 50% of waste and about 40% of CO2 emissions. It's a considerable challenge for the construction and building industry because its objective is not only to save resources for future generations, but also consciousness use of natural fuel, supporting its long-term perspective at the high level, the quality of life for people living and working and spending lots of time in these buildings. This is the aim of international and national green building standards. And this slide shows the main subject areas of my research. So the study, the object of the study is the green tools for construction industry. The subject of the research, the sustainable development for the construction industry, considering ECG principles. Aim is to identify trends in green standard development for international construction practice. And you also see the tasks which were developed and resolved to reach the aim of the research. General trend we have in the construction industry, and it's both in Russia and globally. This trend is related to the increasing demand for energy necessary for the buildings to functions. And if we're talking about the pre-pandemic period, then compared to 2019, in 2020, the energy use decreased quite considerably, and that was by 4%. And this fact was quite clear. The reason for that was quite clear. It was related to the lockdown process. And since majority of you might see the reports by British Petroleum, for instance, you could see that decreased production affected the situation, and of course lower transportation activities. Along with that, according to international evaluations, we forecast growth of energy consumption. This year we will see kind of a stabilization of the situation, increasing by 4 to 6% versus previous year. We will reach the level of 2019. Of course, we talk about there is some it's highly probable, and the most important thing I would like to then say a couple of words about green building standards. Well, things were specific is not construction related. The key basic standard was a British standard, BREEAM. It was the first in 1990. Then it was American lead at GNB, German, and the latest standard, well and fit well. I should say we have lots of organizations related to this industry, like Rossroy. When they develop the green building standards, they actually use existing practices. Of course, when we develop national standards, we consider not only Russian, but also foreign standards. Lots of work was done by multiple experts and organizations. And coming to statistics, we can say that BREEAM is the most flexible standard, and in the whole world, they use it most frequently, and it's highly popular in our country. As to the geography, the most popular and spread standard, though quite strict, is LEED. And why? Because it has quite considerable requirements to design works. They're based on Sharia standards. And talking about the British standards, they use Euro codes and their compatibility, they show much better compatibility. But we consider the Russian national standards and non-obligatory standards of professional communities like STROI. They take into account all three standards. It's LEED, the GNB, and BREEAM. And with regard to American standards, they just start to appear in Russia. And what about considering fit well, there is no clear practice of the application. Although this year we've got the first project to be certified according to the American well standard. And since I have to wrap up, I will just briefly tell you that the specific is related to the fact that we need the necessary attribute for green energy is development of the tools on green funding. This is what we actually do. We created a project, determined key requirements, the great support and assistance is provided by Vneshekonom Bank, which I think will be involved in the control of these activities. They are quite experienced with that. And since I don't have time, I just like to say at the end that the next year we plan to launch those adaptive green tools. It will be extremely important because, as you know, just from 2023 in Russia, they will introduce mandatory carbon reporting, and I hope this next end of Q1 with this there will be marketplace with Sberbank on green certificates. So all these activities will facilitate effective integration of green tools, practical ones, and the best practice, best technologies, active with active implementation and energy storage. And of course, it will affect. It will help us to reach at least some of the indicators on carbon neutrality, which will be defined by the national strategy. Thanks a lot for your attention, and it was a great pleasure. I will answer your questions, Ivani.
Yes, we have a question.
Thanks a lot. I've got two questions. Well, first is about the mentioned foresight. What was the topic of that foresight? How you see the future as a part of this foresight and how it could be reached? That's what you talked about. And second question is about these American standards. The matter is that why they were offered suggested to be used here, because for instance when you go into sell biological additives in the States, FDA will provide you with approvals quite rapid. But if you want to say feeding for animals, you will have to fill tons of papers, and it's really complicated process. And the documenting is a part of the standards. So two questions. What about the future foresight? How you see the future? How to reach it? And second thing, why you suggested to use here American standards? Thank you for your questions. Well, talking about the foresight, and if you mean the strategies of social and economical development, which was adopted the 1st of November. I think it's not me, but the government actually determined that foresight, because I wasn't involved. But of course, these are specific measures mentioned in this document. But talking about this green certification, I'd like to explain it, that the metrics is not a requirement. It's not kind of a duty. No one is forced to do that. I'm an MBA teacher, professor, and I work with the heads of building companies. And many years ago, they asked me, why should we spend 50,000 euro to get some some another certificate for design documents, and one of the big heads, one of the big bosses joined me and said this is a requirement of the foreign investor. On the other hand, we talk about some requirements. Some of the, so to say, some of the requirements, for instance, from FIFA, because all the sport buildings were to be obtained, and they were to be certified by various systems, the international and Russia, the requirements from the Russian Sport Committee. So it's not mandatory certification. Maybe I didn't understand your question right, but I just wanted to say that talking about the bureaucracy and documents, nobody is forced to use the standards. If you see them, it's excessive, that's okay. But just 2 weeks ago, I had a request from the Samolyot top managers. They asked for me to help them to select the standard. They calculate the economical model, and all companies, building companies, they need to survive at the market. We don't see much of the growing of the demand, and the search for new competitive advantages. And along to this, our national standards will be published, and for them to stay within the, so to say, main trend, and to look for some advantages, you see what is actually, so to say, justified. Talking about American standards, I could give you such an example. In Moscow, at the Shlepikhinskaya embankment, the first object, Signy City, that's the first building object, which was certified according to the American standard. Well, it's one of the latest standard appearing here, and the object price is 2 times, not 5%, but 2 times more expensive than another object next to that site, because what they suggest there at this site, specific technologies to purify air with innovative technologies. They fulfill all the highest requirements on the quality of microclimate, and they position this object as an almost the object of the out of town real estate, though it's downtown Moscow, just ecology and microclimate, if I may say so. And so it's quite clear answer. If it's profitable, they sell these square meters twice as they double the price for these square meters, and they already sold almost everything. So because we pay attention to the parameters of the buildings, which are safe and comfortable to live in, and especially business class real estate is expensive per se, and so those people who choose or who look for real estate to buy, they have rather high requirements, and they're quite well qualified. At least in the market, they know what is BREEAM, WIN, or DGNB, and they use the energy effectiveness class and green certificates. So
I know that we have also a question for you in a Zoom conference, but unfortunately, due to the schedule, we will send you this question via email. And now we have to listen to presentation of Grigory Lobatenko. Grigory, are you with us?
Yes, I'm here.
So you know that our schedule is a little bit changed. So are you ready to present now, or it's better to do it after the break?
I'm ready to say it now. Можно перейду на русский. Я, в принципе,
switch to Russian.
Please. No more. Okay, thank you. So it will be the last presentation in this session. Then we have lunch break till 13:30, and then we will continue our session, and we will start with the presentation of Vitaly Bobrov. Thank you.
Ну, давайте без промедления я начну. Тема моего
So I will start without much ado. I'm going to speak about analysis of the provisions of the legislation of the Russian Federation related to the use of the used pipes. So I should say that today, in the course of the whole session, we have mentioned several times that there is the so-called circular economy principles, and Maksim Ivanovich has spoken about it quite extensively. It really exists, and in the course of my presentation, I will also enlighten this issue and give an example of a classical oil and gas company, which at the moment, with the technical development, we cannot reuse the pipes. As it has already been said several times today, there is active planning of this country to modify the energy complex. Within the previous year, we witnessed the release of several provisions and documents which regulate our life up to the year 2035. The president says yes, the energy complex, especially oil and gas, is the main source of income and major object that it supports our economy. Now, let us move on to the oil and gas industry. All the oil and gas companies can be subdivided into three categories. There's upstream, midstream, and downstream companies. If you speak about upstream, this is mining, midstream, this is transportation, and downstream, this is deep processing and selling. In this respect, I would like to speak about optimizing the cost. I'm not speaking about the stock exchange, but the primary cost. So optimizing the cost is, generally speaking, a very sophisticated issue. We know that when we were shifting from the planned economy to market type of economy of contemporary Russia, we paid more attention to the technical and feasibility study. Why do we need it and whether it is profitable and feasible to do so? So whether it is reasonable to cut down on cost, not even cut down, but probably optimized. Let's be more positive. Shifting from one type of economy to another means that we also changed the regulations. If the so-called GOST system, which is very well known to us, sort of standardization is very well known to all of us, the technical regulation allows us to have appropriate turnover of certain products at a territory. For example, it can be Russia. Then how do we verify whether this or that product really complies with the standards? What does our law tell us in terms of the oil and gas companies? The major regulations that come within this area is the federal law number 116 on the safety of hazardous industrial enterprises, and also there are regulations that that set about certain limitations in piping operation. For example, we cannot use the technical solutions, which, for example, reuse of pipes is not possible, it is restricted. But at the moment, there is a practice of applying this approach. If to be brief, we cut out certain pipe during the capital repair. It is checked this or that way, categories assigned to it, and then it is reused, providing the so-called renewability or reuse. But there is an opinion that the new piping should not be used in the repair because, but on the other hand, if you integrate a new pipe into an old piping, then there is no good. to the piping system as such. Now I'm going to speak about the material that the piping is produced from. The metal, as I've already talked about, there is an analogy with so-called decomposition of different metals. How can we test this? This is a study, one of the studies where in Ukhta pipeline, they just cut out pipe 45 years ago. And then after 45, they cut out the same piece of pipe. And they just showed the stress factor. The crystal grid, unfortunately, was changed. And this is related to degradation or depreciation of metal. This is exactly what is forbidden to do. That is why it is forbidden to reuse these pipes. At the moment, I would like to draw your attention to this, that there are basic key cases when this approach is a reason for some catastrophe when, for example, the gas pipes in St. Petersburg were used in household piping, and that was it resulted in a catastrophe. So even if there is some particular frost applied to it, then these pipes started rupturing, and they proved to be not resilient to cold. Also, there is huge market which is related to restoration of pipes. This is one of the companies, and you can see that our regulating agencies, such as Russian Nature Surveillance Agency, detected several companies which were dealing with such products without any appropriate quality assurance, which I suppose is key to it at the time that we live in, that this product should comply with certain standards. As I have very short time left, I can come to the conclusion and say that the analysis of this position tells us about the fact that we are definitely have this situation under-regulated, and we need more regulations in terms of the metal quality, as well as the chemistry and physics of all this process. Application of the product not according to standards, and will result in emergency situations. So,
dear Alexandra, any questions from the Zoom conference?
Yes, there is a question. You are showing the data for 500 violations of the law. What is the data for what period and what region of Russia, and in percent, what is the share from the overall checks? This is the data for the territory of Russian Federation on the whole. The cases are looked into by a particular law enforcement agencies, and also you can find them on the website of our government agencies, and I suppose that the data is not hidden. Thank you.
Thank you. If you have any questions, we will send it to you by email. Dear colleagues, now we have a break in our conference, and we are going to come back at 13:30 Moscow time. Have a nice rest.
Thank you.
Energy. But what is energy really? Is it the jolt of strength we get before we pass the finish line at the end of the race? Is it the inspiration we get when we see something new? Is it the tireless pursuit of trying to move forward? Energy is the power which drives our lives forward everywhere. We have learned to transform it from different sources and to use it at our will. We create energy and we give it direction.
All right, now hold it down.
We are the people who develop the future technologies today. What will they be like? It only depends on us. In the last decades, the vision of energy has significantly changed in many countries. And now, in this period of evident transformation, we can't miss the opportunity to find the answers to the most important questions. What drives the energy industry? What are the directions and tendencies of the energy industry? What lies at the heart of the frontline research? Which applied technology draws the most interest for the Russian industry and for the world industry in general? The leading world scientists, together with the bright minds of the new age from universities and international companies, every day are seeking the answers to these questions. The result of their work will be presented at this international scientific practical conference, Energy Agenda of the Future. We will take a look at energy from a different perspective, in an alternative way. Welcome to the International Conference, Energy Agenda of the Future.
Dear participants, we are going to continue our session, and we ask Mr. Vitaly Bobrov from St. Petersburg State Economic University to present his report with the topic on the specifics of assessing the subject risk of project activities. Also, we ask Mr. Ahmed Talib Ahmed AL-Tam to prepare his presentation next. Dear colleagues, remember about our timing, about our schedule. We will remember you when 1 minute left. Thank you.
Dear colleagues, good afternoon to all of you. Can you see me? Can you hear me? This is good. I would like to speak Russian, and I must apologize for speaking very fast. I will try to speak appropriately, but up to the time frame. So within my presentation, I would like to speak on the interdisciplinary approach to assessing projects in gas companies and oil companies. I'm not speaking about one sphere of economics. I will speak mainly about oil and gas companies in Russia. And we are witnessing actually this transformation for a couple of years. My research will take this industry as an example, and it will allow me to resolve several tasks, both theoretical or scientific and practical. As you know, oil and gas companies or this industry really influences the budget of Russia as a country. It's a key industry, and that is why we're very much interested in supporting very high efficacy of oil and gas companies in Russia. And definitely, this can be provided by different contemporary methods of management, especially if we speak about subjective risks of project activities. There are other companies that also impact us, for example, international policy and interrelation between energetics and other sectors of economy. Such factors are inevitable, and they inevitably can be defeated.
Пожалуйста, нет, тогда сделайте, пожалуйста, полный экран, демонстрацию экрана. Нажмите клавишу F5.
Так.
Нет, хорошо. Мышкой, пожалуйста, кликните на второй слайд слева.
Видны изменения?
Нет. Хорошо, переключайте тогда вот слайды таким образом. Спасибо.
Угу. Сейчас видно.
So now you can see my slide, can't you?
На данный момент я на этом слайде, поэтому, продолжая
So if I continue to speak, then the factors which are listed above inevitably can be reflected in the specifics of the oil and gas project. The specific feature in the area of mining, transportation, and processing can be defined by the limiting the territory of implementation. Also, the high cost and short period of time, which are shown on the slide. And there is inevitable formation of such projects, and it's dependent on the outer factors. The most strategic interests within these oil and gas companies, they can actually depend on a number of external factors, and some of them are of subjective nature, that is, such as intention, mentality of a subject or some group. This way or another, the formation of interest by a stakeholder is quite a comprehensive process. But direction of this interest in this particular project can be not only constructive or neutral, but also we can speak about fuzziness of intentions in a number of stakeholders, especially if it is a destructive character. We have certain type of risks which can also impact the company. There are two approaches to understanding risks. The classical approach is, first of all, determining the risk as a damage, and no classical is a neutral definition. That means it is a deviation of a factual or actual result from the expected one. A company, to effectively perform, we can use risk management. The process of risk management can be different from a risk assessment up to reducing them to the minimum. And alongside with the diversity, we need to use a wide set of instruments and tools in the risk management. These risks can be classified by different signs and principles, which are shown on the slide, from the financial companies and production companies are absolutely different. But there are two separate characteristics for all the risks, according to which we can also classify them and which directly determine the threat of this or that risk. This is probability and consequences. Fuzziness of some stakeholder intentions is shown here. The stakeholders differ in terms of interests and as well as intentions and resources. But let's imagine that the stakeholders' interests, some of them have the interests which are related to risk. That actually means that they are going to harm our project. This is an opportunistic approach, and for such threats, we have subjective risk. So we consider that making it more objective, this opportunistic interest will allow us to improve security for oil and gas companies as well as sustainability. Methods of assessment can be also broken into two categories. Each of them is associated with advantages and disadvantages, and sometimes they cannot be neglected or brought to a minimum. We can analyze subjective risks objectively, and then we shall receive a result which can be used in further mathematical calculations. The quantitative is most the best of all, but there is certain restriction. And in science, when we speak about probability, we mean objective probability, which is based upon the statistical observation or statistical calculation. Examples of such objective probabilities, for example, breakdown of equipment. But we cannot use objective probability to human beings, for example, and behavior of a stakeholder or group of stakeholders in terms of unique oil and gas projects, especially strategic ones, cannot correctly statistically be described. That is why, in terms of such situation, we can use subjective probability assessment. It is different from the objective because it's not a statistical observation, but a confidence of an expert about this or that event. When there is no statistics that can be applied, we can rely upon the expert opinion. This is exactly the approach that we implement in terms of assessing the probability risk of subjective risks. And although this approach is qualitative in its nature, but we propose to apply it by a mathematical background.
Thank you, but we have run out of your time. Can you give us a conclusion? I'm so sorry.
Хорошо. The opportunistic stakeholders and their behavior can be a menace to the subjective risks. And actually assessment such menace can resolve the problem of the lack of statistical data in the behavior of outer stakeholders. So we can use this qualitative assessment and turn it into quantitative data. For example, we can use subjective assessment and improve security of our companies.
Dear colleagues, do you have the questions in the audience? Dear Alexander Parin, do you have questions in the Zoom chat?
Yes, we have a question. The following: whether you can find difference between the subject risks for enterprises and operation activity of a company is different from the project, of course. A project is something that is restricted in time. Activity is continuous. When we look at the oil and gas company and its activity, we usually deal with project activity. They work on the project. And in the majority, this is operation activity, and many of them are of project nature. This is also reflected in the set of risks.
Thank you.
I have a question.
Just a small question, please.
Okay.
Dmitry.
Dear Vitaly, what metrics do you use to assess the subject of risks? Can you comment this metrics for assessing, for estimation, numerical metrics? Or maybe state-of-the-art approaches use some metrics to assess these risks.
I understand you well enough. Yes. Yes, indeed. We were assessing intentions and risks. It's not, of course, a story of the 20th or 21st century. And the state-of-the-art science actually can be thanked for the apparatus of the method of fuzzy sets. And this is exactly what I used when it comes to the subjective methods. We have not used them. When we determined actuality then of the topic, we used questionnaires, risk management analysis, and in ISOs is something that we used.
Dear Vitaly, thank you for your presentation. Thank you for the questions. And now we are going to listen to the next presentation. Yes, Dmitry?
Yes, the next presentation is for Ahmed Talib, feasibility study of projects to improve the energy efficiency of oil and gas facilities using solar power plants. Ahmed, is you ready? Yes, thank you. And for the next presentation, please, Olga Artamonova will be ready. Yes, Ahmed, you can start.
I'm sorry, you can, Ahmed, you can make a full screen.
Yes, yes, yes.
Yeah, the F5 or another mode. Please make a full screen right now because it will be very difficult to change the slides after.
Dear Ahmed, are you here us? As for me, we have problems with.
Oh, okay.
Yes, okay.
Now I hear you. I will share my screen. Is it okay?
No, we can't see in the full mode. Do you use also second display?
I will check.
Please try to present full screen.
Okay, I will share full screen now.
No, unfortunately, we can't see full screen.
So you can change the slides in a panel in the left mode of your screen. So I think it will be the fastest way because full screen mode doesn't work now.
It doesn't work now?
Just click slides at the left panel by mouse.
Okay. Now it's working.
Unfortunately, no. Just put the mouse pointer where the PowerPoint is open.
Okay.
Yeah. Use this method, please. Thank you.
Okay.
Ahmed, are you with us?
Alexandra, maybe we will continue the presentation of Ahmed a little bit later. And during the next presentation, you will try to test the communication. So,
yes, let's proceed for the next.
Yeah, thank you too much. And we ask Olga Artamonova from Electrotechnical University Leti to present her report with the topic maintaining the 5S system in the organization.
I am sorry, it was a mistake.
Hello, once again, Ahmed. We are seeing you. Can you hear us?
Yes.
Okay, back to the beginning. No.
So shall I start?
Hold on a second. Okay, Ahmed, we will see your speech after this presentation. Okay. Okay, Olga, you can start.
Thank you. So I'm glad to welcome you to the Energy Agenda for the Future conference. And today we are going to talk about basic tool of lean production and quality management. I mean 5S system. So in order to consider the topic, we shall determine strengths and weaknesses of the tool and provide simple and clear improvement measures. So the relevance of the presented research is based on the need of organization to sustainable development. Therefore, it needs management system tools, including work environment management, lean organization tools, especially 5S, customizes need of particular organizations to build the value-added process and eliminate wastes from it. So we will consider why different companies has significantly different results. And research is aimed to avoid some of the pitfalls the companies experienced in the past and give some preventive actions to maintain effective 5S. In the research, we studied best practices and unsuccessful experience from different industries, analyzed and systematized the information received. So the main aim of quality management and lean production is to provide adequate system of control, error protection, and continuous improvement. Establishing the value-added process is the main aim of any companies because it is the thing that an external customer is ready to pay for. And we have to build this value-added flow, to let it flow, to eliminate all the weaknesses and mistakes. We know many examples of standard operation procedures, control plans, means of visualization, and foolproof or Poka-Yoka systems. Let's consider 5S as a resource for optimization and continuous improvement. So, what is 5S? All of us feel comfortable when we have clean and convenient workplace, when it is easy to find any means of work or change over absent employees in real or digital workplace. We have 5 steps: sort, set in order, shine, standardize, and sustain any workplace in any company. So 5S workplace organization and standardization are used to organize basic housekeeping activities and standardized material, machinery, manpower, and methodologies used in your value-adding activities. In process of poorly organized or not standardized, it's very difficult to establish continuous flow. I mean value-added flow. This is the reason most organizations begin an implementation of lean with the fundamental introduction of 5S workplace organization and standardization. So, what is the best way to fail 5S activity? That is pretty clear. We have to organize a meeting, shortly present the 5S tool, and say to our employees, do this quickly. That's all. After this, maybe after 1 month, you will check in a glance, not concrete. And after several months, I promise that you will have nothing. Deal with 5S. Why can it happen? Because you have no money or no resources for 5S. We need people, time, and money for organizing new shields or standards or train people to work in the other way. So, and also there is a risk of a conflict between some foreign improvement team which occurred in our old organization and other value-added process owners who is got accustomed to work with previous method. And when we have no control system, we cannot eliminate the risk of this conflict. So let's go through all the 5 steps and check how we can help this situation. In the 3rd step, I ask you to think about which process you have, how many people deal with this process, and what means do they need. And we have to fix it in documents. When you have list of necessary labor tools, location of these tools, or waste, and the ways to eliminate this waste, that's why you can do the sorting procedure in your company. Afterwards, I ask you to set in order all the things you need in your process. So you have list, you have plan, now you organize the replacement and changing the place of the tools. After this, you have to clean up and what is also necessary to check the ability to work. All the wires, all the connections, all the digital systems you need. And we have to find the owners of this process. Who can fix your computer? Who can clean up the room? Who and by why? With help of which things they can do this? That is the aim of the 3rd step. And when some time passed and people try to work in the new sphere and all their problems is fixed, you have to standardize to make and fix the rules of new work life. Any standards you need, some instructions, procedures, checklists, all the plans is here. And finally, we have to sustain our system. When you don't have any control system, everything will be destroyed. In the slides, you can see all the checkpoints will help you in this topic. So the other recommendations to maintain successful 5S system is to provide traceability, transparency, and responsibility of the procedure of 5S. Not to do the project, but do the path. It is endless process and continuous improvement. You cannot clean up for 1 month and forget about this. So the team communication provide the interaction between process owners and our improvement team. When they work together, they have this communication and interrelations. That is very important for our improvement. And for sure, that is motivation system. When we have the status and we appreciate the input of any employees dealt with the system, they feel comfortable and want to do this more. So, and on the other, we have to handle our conflicts when it occurs, but this is the topic of change management. So
Thank you.
That is the finish. Yes. And if you are interested in the topic of quality management and lean production, I ask you to get in touch with me for some joint projects and the further researchers. Thank you.
Thank you too. I know that we have one question from Zoom chat. There is no questions in the audience, as I understand. So, Alexander, please tell us the question.
Вопрос будет следующим. В чем плюсы?
What is the advantages what are the advantages of the system is quite clear, but what are the disadvantages of the system you described you could mention, and how they could be fixed? Thanks a lot for your question. Let's talk Russian a little bit. And we'll come to the causes of reasons of failure. The reason of failure is so to say, compatibilities. So they have some roots. So first, it's lack of resources and it's interested sponsor. So it's all the things, they cost money and time or intention of the management. So if we consider the minus of the system, it means additional workload for the management.
That's it? Yeah, thank you. And now we come back to the report of our colleague, Ahmed AL-Tam. So are you ready to present? We are online.
Yeah, I hope so.
Yeah. Thank you. Please remember about our timing, just 7 minutes.
Yes, we can see presentation, and you can start. But
okay, good day.
But I think you should to click your slides.
Okay, I remember.
Yeah, do it. Mm-hmm.
Okay. Hello everyone, my name is Ahmed and I'm a student in St. Petersburg Mining University, and today I have the honor to be with you, and we will talk about solar energy. As you know, solar energy appears to be one of the most important sources of renewable energy. It's also considered environmentally and friendly as it comes from light and heat. There is a tendency in the world towards the development of green economy, however, to use the solar energy as one of the most and fastest and safe way to provide electricity. Therefore, the desire of innovation in this area has become relevant, not only due to the significant effects in comparison with other energy sources, but also in connection with global environmental and economic policies. Oil and gas enterprises are energy intensive facilities. Disruption for their power supply can lead to disruptions in the technological process of oil and gas production and transportation and any related process, and it may cause for that to significant economic losses. Therefore, the tasks with increasing the reliability of and efficiency of power supply of electrical complex are relevant. The technological innovation are and creative design continue to open up a wide range of energy efficiency opportunities of the oil and gas services, and investments and projects are focusing on the greener infrastructure and more efficient process for oil and gas sector. As our partnerships that support the advancement of energy efficiency research in this industry. As you know, in 2020, Europe unveiled its Green Deal, and it began to develop and make it a reality. The carbon dioxide emissions trading system started in China last year. And in Russia, interest in this topic rose against the background of Europe plans to introduce carbon border tax, and international analytical against began to calculate the potential losses for Russian companies. And at the same time, the authorities began to discuss the possible introduction of regulation of greenhouse gas emissions in Russia. The use of renewable energies is a large area for industries around the world, and the need for efficient technologies to create less wasteful ways to producing consumer materials is becoming more and more important. In other words, alternative energy is any amount of energy derived for non-fossil fuel sources. Generally speaking, the use of alternative energy has any negligible and negligible impact of the environment. You know, maybe the list of some most common sustainable energy sources we use today is wind energy, solar energy, hydropower, geothermal energy, bioenergy, nuclear energy, hydrogen energy, and tidal energy, wave energy. Today, we are going to
1 minute left. Sorry. Just
okay.
remember.
Yeah, I will speak quickly about our project. So what I'm gonna today to tell you about, we have this project in oil and gas field in Iraq, in Romanyuk. So you can see it's a carbon neutral energy supply system project. You can see initial conditions. As you said that I have only 1 minute left, I can show you transmission system project, and then you can see the power supply system project maps. We did 3 options, and the third one was recommended because it was when we if you look to ACABX, it was the best one, and it will cover 91%. So the calculation is on the last slide. I'm ready to answer your questions.
Thank you too much, and thank you for respecting our timing and your conclusions as well. Do we have questions in the audience? Do we have questions in the Zoom chat?
Yes, we have one question to Ahmed. What about the climate risks for alternative energy? If there is no sun, it's raining, no wind, we get the energy crisis like this year in Europe. How to avoid such risks? Thank you.
You mean when there will be environmental problems, how we can resolve this problem? We have we have solution for that. For example, in our company, we have energy storage systems for when there is no sun, for example, or sometimes it may takes a days to for sometimes when it's raining. So we can use those energy storage systems to reduce electricity for homes, for those oil and gas fields where we are working now. And I think this problem is we can resolve, and all our solutions are friendly and environmental.
Thank you too much. Thank you for the questions. Greetings from the audience for your report.
Thank you.
So, Dmitry, who will be the next?
Yes, the next will be Elizaveta Kartashova from Kuzbas State Technical University. their presentation will be online. Dear Elizaveta, is you ready? Thank you. And, the next will Dmitry Stolbov, please will be ready. Yes, Elizaveta, you can start. Видно, но точно так же, как и у всех. И вы можете сделать полный экран?
Возможно, какие-то заминки. Рекомендуем переключать мышкой по левой части экрана, переключать слайдами.
Да, переключайте, пожалуйста, с левой части экрана. Попробуйте кликнуть мышкой.
Да,
вот.
Отлично,
да.
все
Да,
видно.
можете начинать. Спасибо.
The experts, my name is Elizaveta Kartashova. I represent Kuzbas State Technical University, named after Timofey Gorbachev. Today, I would like to talk about methods to assess energy safety of energy system objects. We should start the quality of life as a term of the system of various system of social, economical, and environmental parameters. Their sustainability is actually is affected by energy security, and so it is considered the system actually fulfills its functions in full if the security of citizens, society, and regional economic is actually honored. But it determines the growth of social, economic, and environmental aspects, including at the national level, and decides of the union of the energy system with the consumers, creating the tool to regulate management of with energy resources in accordance to the needs of consumers. Today, implementation of transfer optimization of processes results in brings the energy industry to creation of template methods to search for analysis, the method to analyze and assess energy security. To search for threats and prognosing the appearance, we might use universal methods. Each of them has its advantages and disadvantages. In my study, I would like to discuss three methods to assess energy security. It's indicative methods, methods for hierarchy analysis, and method of fuzzy sets. According to the Ministry of Energy of Russia, by 2035, it is forecasted increased growth for electrical power, which sets an energy security principle in the first place. To use energy sources optimally, we should learn how to analyze them. We should monitor and set those components of the systems which, if changed, might affect the whole energy security system. And the complexity of assessment or evaluation depends on the sources of risk and ability or inability to forecast them. Any system of assessing energy security should be simple for evaluation and should be rapid when responding to them. The most easily to use the simplest indicative method. This is the method could be used as a foundation for a more comprehensive hierarchy approach. Limits of accuracy of hierarchy methods are increased through by going to the fuzzy set methods. So each method actually describes more accurately indicator change levels and improves the range of detected threats. Indicators for all methods to assess energy security is an indicators or parameters of external or internal environment of the object of the system, which affect directly or indirectly the object. For all methods, we can use similar criteria, but they have different completeness and scope. The basis of indicative method is criteria used to assess energy security. Each indicator has its normal and critical values, which we use to assess if the parameters are normal or abnormal. The more indicators we have, the more accurate is assessment. The indicators per se and their limit values are formed through analysis of resources and energy resources of the region, financial parameters, energy infrastructure. The disadvantage of the method is appearance of obsolete indicators, appearance of new ones in the long term. That's why it's another method for indicator ranging from the point of view of priorities for regional development. This method is called method for hierarchy analysis. Depending on which plan of energy development is most important for the specific subject or region, we can talk about specific criteria which could affect its achievement. Selected indicators are allocated with a specific, so to say, importance group. And the threshold for more important criteria compared with normal values and planned ones. Diagnosis of energy security is a part of multifactorial analysis. That's why during the general evaluation, it's better to switch from quantitative assessments to a qualitative, a verbal one. However, when we switch to a fuzzy set method, determination of the limits of threshold values from parameters high and low, we should use a math system. That's why the fuzzy methods, this criteria adds some changeability, meaning the parameters are described with functions. Function selection depends on the changes of the parameters with the development of some of the factors. The limits between normal values and critical are, so to say, not quite certain. Suggested indicators create some sets where all criteria have several similar value to assess energy security. Growth of separate positive criteria is associated with the change of the general security level of the object. There is a dependence of criteria on the significance of the consumer scope. Let's look at this table. With this criteria, the fraction of own sources in the energy balance of object cannot be applied to the object to such object as a, so to say, as a manufacturer, since there are no fraction to assess. So on the other hand, it's possible to assess quantitative parameters for the criteria portion of the largest unit of the generation of the set object. So in this analysis, we can assess the suggestions as a selection of the method to assess energy security is directly proportional to the assessment of the energy security. This new method also more accurately describes indicator allocation, and it increases the range of detected threats. Besides methods, those methods I mentioned, there are alternative variants like so for instance, we can use less spread methods, the monitoring method, which assumes individual analysis and calculation for all parameters of energy objects. We cannot use this method at the scope of the whole country because it's impossible completely to assess all the parameters with all the objects, but we can use it along with the indicative method, with a hierarchy analysis method or fuzzy set methods to obtain more accurate results at the end of the day. Absolutely different method is a method so-called expert opinion. This method is hardly to be implemented to other more conventional methods, but it could add up to our analysis criteria. Energy security stimulates economical growth of the country and region in general. Energy consumption could be called as a main factor for sustainable development of the manufacturers in modern society. Still, our energy system in our country is in crisis. In several regions of the country, we see a failure growth from 15 to 190% due to the equipment deterioration of the grid. This pie chart shows that the fraction of generating equipment produced after 21 is just 6.5% of used equipment. The diagram of the age of grid lines also confirms the need for them to be improved. Introducing criteria for assessment of energy security, we can prevent multiple failures, increase quality of electric power, and it's uninterruptible, so to say, supply. Yes, there is a Zoom question. Is it only by introduction criteria for assessment of energy security we could prevent development of failures because it would require lots of resources? Yes, our criteria will be a great, so to say, basis for further development. We might work on development of the neural network, which would simplify the process, which will cheapen it. But of course, if manufacturers are not ready to such developments, it can hardly, of course, strongly influence energy security at the national level.
Our greetings from the audience.
Thank you. And the next presentation will be from Alexander Kochudikov and Vitaly Moromov. The presentation will be here, and the next will be Svetlana Fedorova from UMC Technical University. Thank you.
Добрый день, уважаемые коллеги. Вашему вниманию мы бы хотели предоставить.
Good afternoon, dear colleagues. I would like to speak about a smart city, the concept of digital transformation of SST Ijevsk. The development of energetics is closely intertwined with the digitalization and the data, big data technology. Presence of one data and absence of the other would entail economic loss as well as poor quality of products. Implementation of digital IT and smart systems will allow us to look at the industry from a different perspective. Modeling of technological processes as well as big data analysis and neural networks, these are the tools which we cannot achieve any progress without. Our company is represented in 13 regions of Russia. We have 58 stations, power stations, and within the scope of our company. Apart from the very high parameter of generation, we also have high other high parameters, and the loss, energy loss, and is at a minimum, and the potential of our Ijevsk power units is really important for us. So we think about integration into digital systems and making it smarter. To do so, we scrutinize the international experience of implementation of such smart technologies and digitalization, and we developed particular checkpoints for the project. Thus, implementing the optimizing and the digital processes will allow us to achieve state-of-the-art power supply systems. The main goal is to bring down capital and operation costs, as well as improve and optimize distribution system. We developed a digitalization system, but we did not forget the operation processes as well as the personnel, because it's very important who is going to use these systems and how they're going to incorporate into our systems. Vitaly will continue. Dear colleagues, dear audience. So in the frameworks of digitalization, we consider that there will be automated system, which is AVS. This is a designated system for generation, distribution, and consumption of electrical power. This model of AVS or AMS, excuse me, is provided here. According to our opinion, AMS will allow us to flexibly manage the smart control system, improve the efficacy of investment, and will bring down the loss. AMS system is a three-tier structure. The low tier is cumulative number of sensors and indicators which are required for technological parameters of the equipment. The mean level is the so-called local AMS, and the upper tier, these are servers and also AMS, which collects and stores data which come from the local AMS of mid-level, and also general management and control of the system. Digitalization of key areas in production management will increase productivity, and it will improve HR, exploitation, logistics, transportation. This, of course, will result in the reduction of trauma at an enterprise, optimizing productivity level and the reduction of the working load, as well as improvement in design, production of spare parts, as well as loss prevention of lost working time. Also, it requires particular communication channel where, by means of IT, there will be archiving system, as well as the data storage and data transfer. All the information received will be pooled in the management and control system, where we shall implement automated identification, control, and management. Identification of any deviations will also happen within this unit. In conclusion of my presentation, I would like to say that our concept was planned for the 15 years period. The overall profitability considers the general effects or general parameters, such as, for example, fuel cost, and also systemic economic effects, such as reduction of capital investment for fuel procurement, and also smoothing the consumption peaks and improving the throughput in the inter-system connections. The implementation of this program will improve the transparency of business, security of a power unit as such, as well as the quality of the power resource which we provide our customers with. This is the end of our talk. You're welcome.
Questions? Yes.
Questions from the audience.
Hello, thank you very much for the talk. I have a comment from Noyabrsk Energoneft. You conduct digitalization, automation. As a result, we have lots of sensors, diagnostic levels. I have a question whether you have planned predictive analytics, whether you are going to detect and forecast the failure of some of the units or the whole equipment. Yes, thank you very much. This way or another, you are quite right. If we speak about a lower tier of digitalization of a power unit, indeed, this means great deal of low tier sensors, which will be responsible for temperature measurement and other measurements, other metrics. Indeed, we have been asking ourselves these issues. There is some experience, and as in Izhevsk, we have already started automation of power units. That's why we already have developed the strategy, and the number of failures of the low tier sensors is not that drastic, and it doesn't happen very often. As the equipment which is provided to us, by all means, works, functions, and has its certain expiry period. Are you going to implement some ready system, or are you going to assemble a completely new system from the sensors up to deployment and commissioning? The situation in Izhevsk is such that the lower tier is being implemented, not 100%, the middle tier, like in power stations, generators. All this information is sent to the dispatcher control point, and the upper tier. We have such developments as Termes, and we have examples in Yekaterinburg, which is also run by our company. We have fully implemented two-tier control system with the hydraulic control, which and the power unit has a digital twin, and all the parameters are collected there. So we are actually undergoing or halfway through. Thank you. Thank you very much. Any more questions? Thank you. I come from the St. Petersburg Polytechnical University, named after Peter the Great. So do you have any results on the loss in the energy networks? Because or are they just pure calculations? Because the calculations have already been there for a number of years, but I have not seen any actual results. Yes, we have results. But I would like to say that it's not just digitalization that allows us to achieve certain results, but also we have comprehensive approach to this situation. We have also quite an important program on modernizing the generators in Izhevsky Power Plant 1 and 2. We have new boilers, for example, in the framework of this project. We change quite a lot, like turbines. All this in a complex allows us to achieve good results in terms of curbing losses. For instance, the annual loss ranged approximately at 900 kilocalories per year. What about percentage? I mean, loss inside the networks. I just know out of my experience of analyzing, more than 10%. I can say that from 900, we reduced it to 700. Well, but that depends on consumption. It could be actually something higher, but not lower even. Are there any actual data on the loss before and after? Because in the majority of thermal networks or heating networks, actually nobody knows. Well, yes, previously we were calculating all this loss volume. But for us, for business, it's very important to understand the digits, the figures. So for this, we implement all these solutions and we propose and put them through. Indeed, previously it was just a calculated balance. And now when we apply these digital methods, understand where and how it is derived, I suppose it will be confirmed. In terms of percents, I cannot tell you, unfortunately. Maybe I will calculate it in percent and come back to it later.
And give the emails. So thank you so much for the report. And I know that we have some one question in a Zoom chat, but unfortunately we have run out of our time. So our moderator will send it to you, this question. Okay? So thank you. And now we're going to listen to the next presentation, which will be made by Svetlana Fedorova from Technical University. Svetlana, are you with us?
Yes.
Hello, nice to meet you.
To hear you.
Yeah. And please, we ask to respect our timing, so no more than 7 minutes. Thank you. Yes.
You see my talk? Yes. I'll try to be short since I don't have much time.
My report is in English, but question I'd like to be my name is Svetlana Fedorova. I work for the Ural Mining and Metallurgical Company, Technical University, as the Deputy Director of Higher Education and Head of Energy Department. I'm grateful to organizers of this conference for the opportunity to present some results of our research on the scene knowledge management in the corporate learning system based on international standards on the example of educational programs in the direction of electrical power engineering and electrical engineering. Now it's a bit about our company. Ural Mining and the Metallurgical Company, one of the top Russian producers of major commodities, including copper, zinc, coal, gold, and silver. Additionally, our company produces lead, selenium, tellurium, cadmium, and indium. Our strategy is to unlock maximum potential of our business activities and to sustain competitiveness as a global player on the markets of non-ferrous and metals and coal. Technical university as an integral part of company stands for corporate means of qualification development, basic principles, education, occupational standards, interconnection between educational and production processes, solving of actual production tasks. The engineer of the future faces specific requirements, including the new activities as well as the ability of anticipatory problem formulation and solving. Company raises the questions before university how to prepare personnel who will implement the strategy in a new environment. And how to develop creative engineers to be able to work in a new environment. And so the purpose of our research is to systematize the activity of a corporate university and to organizationally and methodologically support the main engineering training of bachelors on competence and process basis. The first the main objectives were as follows: to look into applied aspects of the main engineering training of bachelors in terms of technical university, to conceptually formulate a management model of the organizational and methodological support of the training process, considering corporate patterns, to experimentally work on model validation. The next step was solving problem to substantiate a set of methodological approaches for the development of knowledge management algorithm, adapt the standardized stages of knowledge management to the conditions of the corporate training unit and test the proposed developments. We developed the model is based on the process-oriented approach, according to which activity is a combination of interrelated processes, basic, managerial, and auxiliary.
I'm so sorry, 1 minute left.
Yes. How we do it? For example, we have 3 teachers for discipline, metrology, standardization, and certification. Thus, the student in connected with production, not only during the practice, but also during the theoretical training. The next stage of the research was the development of an educational model into a knowledge management system. And one example of our research in our university. You can see the system of knowledge management algorithm, and on the principle of the implementation of the master's program. This is how we solve the company's problem requiring scientific research. And okay. Finally, I'd like to show our educational environment, intellectual laboratories. Our laboratories represents in integration of physical stands with 3D models of real equipment and technological processes at the enterprises of the mining and metallurgical complex. VR simulators are able to prepare students for various emergency situations. And in conclusion, we emphasize the management activity associated with knowledge management has its own methodology, essence, and structure, which can be rationally embedded into the current management system in terms of auxiliary processes of HR management. And effective knowledge management should make a positive contribution to all components of the intellectual capital of the organization, forming a unified system of corporate training. Thank you for your attention.
Thank you, Joe. Any questions? Just one short question, please.
Thank you very much. I have a couple questions about. Thank you very much. I have a couple questions about engineering cases methodology. Have you already developed engineering cases, and how many? And do you use them in educational process? Thank you.
So, do you have engineering cases, and how many of them, and do you use them for your educational process? Thank you. I can hardly hear you, so regretfully. Well, case technology is one of the leading technologies, which is quite fundamental for us, because we have very short chain between education and employee and employer. So with energy services of our company, we take real life situations, which we then resolve as a part of research projects, and we transform them into the educational cases, both for bachelors and masters.
The next question, please.
Thanks a lot for your great talk. Could you tell me, please, how you assess effectiveness of your training process? Could you say it more loud? Effectiveness of the training process, how you evaluate it? Well, it's a very important issue. And first of all, it's very important for our employer. Well, we've developed a system, as in all universities, we have an internal quality control system, but it's external since our employer assesses it. I can tell about that in more details. We can discuss it, but just imagine that it's any diploma, any graduate's work of our bachelors, their real life. We don't have theoretical works. The employer provides us with such a real life production tasks. And also there is assessment of the personnel in the company. One of them is 360 degrees. Another one is called, which is an assessment to evaluate professional competences. We adopted this in-company assessment. We adopted it at the university, and the participants or experts are either the employees of the company from various services. In my case, in this case, we talk about the energy service case, or there could be representatives of other sectors of the company.
Zoom chat, and we will send you this question via email. So thank you too much for your presentation. And Dmitry, who will be the next?
Yes, for the next presentation, please, Anna Svetkovskaya from Zarubezhneft. Anna, is you ready?
Yes.
Thank you. And for the next, please will be ready, Elizaveta Medvedeva. Anna, you can start. Да, слышно хорошо. We can hear you and we can see your presentation. Yes, you can start.
Great. So return to the Russian language and start my
So the year 2021 has become a year where the paradigm of oil and gas changed, and we have three letters, E, C, and G. The Sustainable Development Principles allow us and require actually to change our principles of social responsibility as well as ecological approaches and also responsibility to the consumers. Please allow me to ask a question, whether you have debts. I suppose that the very first that come from you will be no, because everybody is absolutely responsible in terms of paying the bills. But I will actually I will disappoint you, because this is the day of eco debt. We have actually used and utilized all the resources that our planet can cost for us. So actually, apart from loving nature, I also like mining a lot. And as Saint-Exupéry said, you get up in the morning, you wash yourself, and then you clean yourself, and then you have to clean your planet. Now let's look.
Sorry, your presentation is not changed.
It's okay.
You can. Okay, now it's okay. Thank you.
Within 2020, we mined 2.5 million tons of oil, and also almost the same amount of by water. And apart from that, 196 cubical meters of by gas, 62% of which we used for power generation, or also utilized anyhow differently. But 30% is also a negative environmental impact that you see in this slide. So one of these points, each of these points is actually a flare of gas combustion. And I suppose that, of course, you don't want to see this wonderful picture for 2020, because of the 75 million cubical meters of bypass gas combustion, about 5,000 tons of greenhouse gases were emitted. Subsequently, it also cost money. It's not a surprise that nobody likes this data, neither investors nor regulators. In relation to this, there is a program of sustainable development, which is about motivation of companies and business communities. When it comes to what we do within our company, most topical are the issues of decarbonization and carbon footprint reduction. Let's look at the use of secondary resources, as well as technology of storage for carbon. Now let's look at the utilization of biogas. This is combustion, back pumping, processing. According to analytics, the most costly is energy generation. Deep processing of components is the most energy efficient, and the combustion is maximum unfriendly to the environment. Also, we do not pay attention to the back pumping because of the huge diversity in the assessments and feasibility parameters. This is related to the technological parameters as well as the economical parameters, which are at the moment still under research. Let's look at the gas injection to the reservoir. So we can. Okay. So this means burial of the gas or injection or back pumping into the reservoir for further use. The method is good enough, but for me, being a developer of oil fields, this is, for me, it's most important in order to have better oil production parameters. There are two types of gas injection methods. This is mixing and non-mixing modes. Thanks to the gas injection to the reservoir, we can have better oil output because of the mixture that we get inside. Subsequently, in order to assess our mine, our field, we calculated the CO2 content in our biogas in a small amount, approximately 2%, but it can additionally be trapped. But even this volume is not sufficient to implement the gas reservoir fully. But such method can be used. It must be assessed further. And every enterprise, any oil and gas enterprise must come to assess their opportunities for gas injection to be more responsible in terms of using resources. And I suppose we should not forget that we are dealing with the development and of oil fields and mining.
No questions from the audience, and I know that there is a question in Zoom chat, so now our tech moderator will send you this question via chat. Thank you, and due to the request of our current participants, we kindly ask to Miss Elizaveta Kartashova to wait a little bit, and we kindly ask to Miss Alyona Krieger to present her speech and her report. Alyona Krieger represents Noyabrsk Neftegas, and her report, re-engineering of the industrial zone heat supply system.
Друзья, добрый день. Представляю вам тему своего проекта «Энергосервисный контракт».
Good day, dear friends. I'd like to introduce myself. Energy performance contract with Gazprom LNG, engineering of the technological heat supply system in the industrial zone Volgapkina. Today, it's very relevant the topic of gradually growing topic on services. The tariffs for thermal energy in Gapur Vodokanal increased 10%. It affects not only the upstream neft, but also Gazprom Neft LNG, because both companies use heat energy at Mingapurovsk industrial zones. Also, there's a problem of the use of the tail asset equipment. These are sites with dropping, so to say, performance. One of them is located at the Uburneft. It's owned by Skromneft LNG, and once it's closed, there's a problem of how to use the equipment with still existing useful potential. The problem is to create an energy service, energy performance contract with Gazprom Neft LNG in order to change technological system to Vinga-Perkursky micro districts. For that, we have several goals. We need to analyze current situation and calculate to do cost analysis of actual use of terminology and annual growth of tariffs, to consider options of modernization using the useful potential of the closing tail assets, and also calculate economic indicators of the project, assessing the effect of the subsequent events. What is the energy performance contract? It's a specific form of the agreement which is aimed to save funds of the customer through energy sparing and implementation of energy effective technologies. How it goes: the customer, to decrease energy costs, executes a contract with energy service company, which implements a set of measures to improve energy effectiveness and save energy resources. During the contract, the costs of energy service company are, so to say, reimbursed due to the higher energy effectiveness. At the end of the day, the customer actually saves, so to say, actual funds. So let's analyze current situation. Here is a part of the structural scheme of Volgapkirovsky heat supply system. We'll talk about three organizations using heat energy from VTVK. It's Niemb Energoneft, Gazprom Neft Energy, and Yamal Spet Center, which actually runs the equipment from energy. The forecast use of heat energy from all those units is about 5,100 kilocalories. It's about 13 million rubles. Due to the increased tariffs, the costs of that process will increase with each year. As this slide, you see the proposed modernization scheme. Within the framework project, we plan to close infrastructure and redistricate the boiler from Wiedenburg River to industrial zone of Volgapkirovsky project and integrate it into existing heating system. Thus, we will not need to buy thermal energy from VTVK, producing our own thermal energy. Also, will help to the customer to use more effectively their main assets. Also see calculated parameters of operational costs during the project. It includes the cost of cheap energy to buy thermal energy, and for NAN, it is a cost for rental of the equipment and servicing of the boiler, and also transportation of oil, gas, and energy spending for grid pumps. And to implement it, we need to introduce several solutions. The draft and relocation of the boiler room, changing of the oil burners to the fuel ones, or to the gas burners. Also, we should introduce the piping as a chimney, and also re-equip the boiler. And the last, we should conduct technical diagnostics of all the devices. So we're going to have the roadmap based on the existing experience of the boiler movement. It will last about 8 months. At the beginning of the year, we plan to buy equipment and execute all the contracts, then all the construction works and installation, and then we're going to, so to say, start the gas equipment. What will company will gain from it? Well, before the contract, both companies use thermal energy from VTVK. Then after the contract, you will produce your own energy and will not use thermal energy from VTVK. The boiler will be leased by NN. Investments will be compensated through energy performance contracts. Gazprom Neft Energy will get lease payments. Implementing of the project due to the development of their own energy will help us to save quite considerable money. In total, it's about 11.5 million rubles. It's the first year after the project is implemented. Along with it, we'll be able to effectively use the equipment of the deposit sites with already a low amount of, so to say, performance. Also, by switching from the oil burners to gas one, we will diminish carbon trace, because gas burners produce minimal amount of carbon trace versus oil use. Besides, the energy performance contracts for Gazprom Neft Energy will help us to use this mechanism of solution for both within the GPN group and at the external market. Project of that type are a priority for Niemb Energoneft, since we can use modern technological solutions and introduce them in the future Center for Energy System Management. Thanks a lot for your attention. Thanks a lot, Alyona. Are there any questions? Hello, Polytechnical University of St. Petersburg. So what is the time frame of this contract? What is the cost of this contract? And if I understood you right, the energy performance contract executor is a subsidiary of the main company. Neft, yes, is an executor of the contract. It is ordered by GPN Energy. The time and duration of the contract, energy performance contract, like cost effectiveness and duration, they will be discussed after this project is coordinated with customers. So we don't have any specific time frame at the moment.
Thank you. The last question, please.
В рамках данного проекта
within this project, have you considered what will happen with the heat generating equipment of VTVK? And is it possible to relocate it, target it? Because you will diminish the environmental effect. Because you consider environmental effect because here you double carbon heat. Because you will produce your own energy and VTVK also, but we refuse of using thermal energy. So that boiler will be closed? No, it won't be closed. There are some other consumers with that boiler, but we have our own boiler, which will provide heat to us. So there is actually no positive environmental effect. Why not? In this case, this boiler uses oil fuel. Environmental effect is that we will switch from oil burners to gas burners, so we will decrease the carbon trace.
Thank you too much. Greetings from the audience.
Большое спасибо.
Alyona Krieger from Novikova.
The next, please, Elizaveta Medvedeva from Financial University under the government of the Russian Federation. Hydrogen as a basis for new energy transition. The presentation will be online. Dear Elizaveta, is you ready?
Подскажите, пожалуйста, виден ли экран?
Okay. And the next will be Alexandra Vozian from Petrograd, St. Petersburg Polytechnic University. Elizaveta, you can start.
Dear colleagues, I'm very happy to welcome everyone. And today we have already discussed the topic of hydrogen. So I will continue this topic with great pleasure. I'm going to speak about hydrogen as the basis for new energy transition. Today I will speak about relevance of the topic, research methods that I used, hydrogen rainbow, transition from gray hydrogen, also the benefits of hydrogen, required investment, effective regulations, international cooperation, and results. Today, we are undergoing the fourth transition, I mean renewable sources of energy. This happens because of the depletion of fossil fuels and global warming as well. So one of the ways out is hydrogen energetics. It is the most widespread chemical element, has big number of molecular combinations with other elements, and can become very good instrument of the energy production. Also, it is environmentally friendly, and also it can be used in energy production. And also it's good for the existing ecological requirements. We use such methods as comparative analysis of statistical data, big data analysis, global energy market analysis in our research was used, and also we looked at the industry. One of the main criteria of hydrogen rainbow is its environmentally friendliness. It could be 6 types of hydrogen: gray, which is carbon dioxide, which can occur in the atmosphere, then blue by blue conversion of methane, and also it accumulates in the storage systems, brown as mining of brown coal, and also turquoise, yellow as a result of electrolysis of energy sources, and green. This sort of hydrogen is most environmentally friendly, as it is a result of electrolysis from renewable energy sources. this type of electrolysis that will require great deal of expenditure. So it accounts only for 2%, and 75 is natural gas as a source of hydrogen. You can see who deals with this quite actively. This is Japan and European countries, as well as Northern America. In the Middle East, and they lag behind this project approximately several decades. And I suppose that shifting or transition to hydrogen energetics definitely will help us to reach the sustainable development goal. Approximately by 2050, the North America, Europe, and China will become the largest consumption of hydrogen, approximately 45%. The benefits of hydrogen are obvious. Many specialists at the moment are trying to forecast perspectives by 2030, annual hydrogen demand growth of 100 to 114 million tons, and by 2050, hydrogen will cover 18% of the world's energy demand. More to that, the hydrogen plays a very important role for the transportation and metallurgic industry. There are three major benefits of hydrogen: environmental benchmarks, leading positions in the industrial technology, and energy security. Also, from the viewpoint of the necessary investments, you can base upon three major factors, which will also speed up or accelerate the distribution. This is the relationship of fuel cell expansion, low prices for the infrastructure, and also high price of infrastructure and fuel cell for hydrogen production. The last factor is the price competition of investments in projects to develop new energy sources. So we should also mention that investment risks can be mitigated, which will set up a much better environment for the private capital and investment in the hydrogen technologies. I would like to say that up to 2030, we see progressive figures and very good prospects, approximately of 14 million tons per year. Effective regulation is definitely needed, and the creation of regulation must be there. This is tax benefits as well as legalized means. Also, we need intersectoral cooperation in order to set up national and international plans and concepts. So the state definitely must mitigate the risks, and it plays an important role for the investment projects. From the viewpoint of international cooperation, at the moment we have several programs, such as, for example, Citygate project, also H2 mobility project, and many others. Thus, international cooperation facilitates investment into cycle programs, innovations, and coming to the results. If you come to analyze the industry structure and specifics of the hydrogen raw materials market, then we need a transition from the gray hydrogen to green. Thus, hydrogen energetics is an important part of the global transition to the new environmentally free energetics. I will be happy to take your questions.
Just one short question, please.
Благодарю. Ну, я, наверное, сейчас выступлю как бы в такой роли немножко злого полицейского.
I will be a bad cop now.
Значит, ну, вопрос такой комментарий.
There is a question and a comment in one. You somehow evaluated, I suppose, the steam emissions into the atmosphere. If CO2 can be trapped by trees and the chlorophyll actually turns it into more positive substance, then what about the steam? This is greenhouse gas by its consequences, it is much less environmentally friendly than CO2 and the big data. What did you use in this particular case? What did you come to analyze? Thank you very much for your question or questions. The first comment, I can respond to it in the following way. From the viewpoint of technology at the moment, we have new production conditions as well as transportation and storage of hydrogen, which will allow us to reduce the emissions. About the big data, we have looked into analytical data of energy companies of different countries. The prospects for every country in terms of shifting to green economy, and also from the viewpoint of prospects of analysis.
Audience for you, and also we kindly ask to prepare her presentation Ms. Alexandra Vozyan, Petersburg St. Petersburg Polytechnical University, and we ask to be prepared to Ms. Anastasia Aristova, also presents Petersburg St. Petersburg Polytechnical University. And dear colleagues, we have one request, because due to the time schedule, we kindly ask to prepare a presentation in 5 minutes. I know that it's not so clear, it's not so easy, but we tend to spend more time on questions and discussion. So thank you. Alexandra, are you doing with us? Okay, we see your presentation, so please launch the full mode. Slide presentation, slide mode, please.
Не, ребят, пожалуйста, у вас второй монитор или проектор включен? Коллеги, у вас, скажите, у вас включен второй монитор или проектор? Нет, нет такого у вас, потому что у вас презентация не в полноэкранном режиме. Хорошо, окей, вы можете кликать вот по слайдам? Все, сейчас все хорошо, спасибо.
To the participants, we're a team from St. Petersburg Polytechnical University. We introduce our talk on carbon neutrality stage of St. Petersburg automotive industry enterprises. The connection is extremely poor and the sound quality is extremely poor. So we cannot hear you. We cannot hear the speakers. I'm sorry for that.
Can you please test your sound?
Dear colleagues, maybe let's try. Say something, please.
Скажите пару слов, ребят.
Could you say something, please?
In this case, I suggest the report with Alexander Parin in order to test the presentation, and the next presenter, Anastasia Aristova. Are you ready to present now?
Yes.
Please launch your presentation. And Alexander Vazian, please connect to our technical moderator, Alexander Parin, in order to test your connection. So thank you. And after Anastasia Aristov, we are going to listen to Alexander Lin.
Yes, we can see us.
Can you show a screen?
Please share full screen for us. Yes, yes, it's good. We can see full screen. You can start.
Hi to all the participants. My name is Elizaveta Anastasia, and I would like to talk about comparative characteristics of the prospects for the development of bioenergy in Russia and China. During the last decade, leading countries of the world paid lots of attention to the use of energy from the renewable resources, including bioenergetics. And according to Global Bank assessment, about 2.5 billion ton. So we need to use something with the waste and to reach ecological closeness of the production cycle and to switch into the circular economy. We need to look at the volume resource-based state of the energy development and the ability of regulatory and legal state support in Russia and China. In Russia, biomass is a leader with a great potential for energy production in all time of RES. Usually, annually produce about 15 billion tons of biomass. This is energy of 8 billion tons of conditional fuel. With biomass fuel is 1 billion tons of standard coal. Produced biomass in China and Russia could nicely utilize waste of the agriculture business. It's also said we should take into account importance use as a fuel raw materials, the solid waste, which actually today produce lots of problems for recycling. Considering the current power generation in Russia and China, the most popular type of generation is heat generation on coal and natural gas, and then we have hydro plants. And production of we have more of energy producing nuclear stations only in Russia. Bioenergy is not considerable, doesn't play a considerable part, though there is a vector for development of bioenergy in China. Considering the total electricity production through traditional generation, as you can see as a figure 2, the production of electrical power in China grows steadily, despite current crisis. And Russia is a leader on production of various types of biofuel through the energy production through biomass. Our situation is different from China. Unlike in Russia, biogeneration in China is produces 10 times more for electric power, and electric power in Russia and China produced with bioenergy and biotechnologies produce 11, 14, and 19,000 megawatts annual. These differences for biomass energy production actually are conditioned with a huge requirements for energy huge demand for energy in China's so say industry. Also very important is state support with proper legal framework. The basic source for funding of bioenergy in Russia is the finances of the subjects of the Russian Federation and the federal budget. Also, funding is provided through the funds from the international corporations and medium and small size factories, but it is not considerably large versus China. And at the moment, current growth of global and domestic waste states a very important issue. We can use a biogas plant for that. And capacities of biogas plants of the Russian and China production from energy complexes are different, but not considerably. That's why current technologies in China and Russia are at the same level. For more detailed comparison of these parameters, we need to consider the method for selection of the optimal composition of substrate to produce the maximum uninterruptible bioenergy production. As a conclusion, I would like to say that the vector of the melt of the policy of energy production in the Russian Federation is aimed to support programs for production of various bioenergy types at the international market, including biogas. One of the main causes of the success of bioenergy in China is a great fraction of private investments, which we do not have in Russia. Perspectives of development of bioenergy in Russia and China actually are fixed with the state support. By 2030, the total power production based on bioenergy in Russia will reach 26 gigawatts, and in China 30 gigawatts. So the future of bioenergy is quite promising both in Russia and in China. And thank you for your attention. And I'm ready for your questions.
Ivan. I see there is no questions from the audience. Thank you. If there will be questions, we will send you to email. And now we are going to listen our last presentation in this section. It will be made by Alexander Ilyin. Are you with us? Hello.
Yes, good day, dear colleagues.
So we asked to make a presentation, and unfortunately, due to our time schedule, we will be thankful if your presentation will not last than 5 minutes. Thank you.
I will do my best. Dear colleagues, please, will you kindly help me with the slides? We cannot see your slides so far. Now we can see it.
Да, коллеги, добрый день, Ирина Александровна.
Dear colleagues, I'm going to speak about relevancy of taking into account the consumer's important source. So some technical hindrances, of course, may occur in the energetics and the market, in the market conditions. Reliability is a very important task. Security and reliability is one of the parameters of energy strategy of Russia. We have problems with obsolete equipment, and this is an acute issue. Depreciation of the backbone networks of power FSK is approximately 50%. The mean depreciation by 2025 will surpass 60% in some region. The situation is even worse. For example, in Smolensk subsidiary, and Smolensk is approximately 80%, and 77% in Tuva region. In Tver, excuse me. Is everything all right with the sound? Good. So I would like to say that the network equipment, I must apologize, but the translation is not possible because we have sound problems. There is a problem of ranking maintenance measures and capital repair. They're simultaneous. Simultaneously, it is impossible to be done because of very high cost. And if at the moment we have developed a set of technical measures for the customers that will improve security of energy transfer. So we have sometimes ungrounded and random measures, which of course are low in their efficacy and do not provide with tangible results. When it comes to the repair calculations, the calculations are quite time-consuming, tiring, and there is no particular criteria which will allow us to do the ranging according to which these events must follow. Also, we need to take into account such parameters, importance, source of the customer. First of all, this is particular dependence on the company, and it also can be what else we can take into account is the interrelation between and the damage for the customer, which is first of all the damage not only for the consumer company but also environmental and social risks. Now, let's look at the concept of sustainable development. According to this, we can look at three directions: economic, environmental, and social. Social and ecological or environmental can be seen within this strategy. And sustainable development standards or disrupted energy provision can actually result in different outcomes. They must be appropriate internal priorities as well as the environmental, social development and corporate management. We can speak about the following risks, which are described on the screen. We're not going to read them out. This slide also shows an interrelation between different stakeholders, external and internal. External are the customers, different type of municipal authorities, and also there are internal stakeholders. That means managers and employees of a company. You can see the power grid company and how it is organized. Now, in order to improve security, we also need to have this list of consumer ranging, which will definitely depend on the damage that can be incurred because of the interruption in energy supply. So we should definitely assess it from the viewpoint of technological process of a customer. Apart from the technological process, also climatic region should be taken into account. Subsequently, the customer must be subdivided into several groups according to the technological process and climate specifics. The complexity of such assessment lies within incomplete data for particular economic calculation, as well as time, as well as very tedious process. In order to assess this, we need some digitalization, which is very difficult to achieve as well. As we are sparse in data, the probability theory cannot be used. Subsequently, we analyzed two different approaches. First is the algorithm for assessing the importance source of customers using the theory of generalized fuzzy numbers, or GFN, and another algorithmic assessment which is based upon the scenario approach for calculating the possible consequences of a power failure. It can be used by expert assessment alongside with the statistical data on the electricity cuts. We used real-life sampling of a network company. Subsequently, we came to the conclusion that the best variant is integrative algorithm. But if the data is sparse, then it is quite reasonable to use another algorithm of GFN. In conclusion, I would like to say that to improve the reliability of power supply, the program of repair measures should be drawn up, taking into account the importance score of consumers. The assessment of such must be carried out in accordance with the possible consequences that unreliable power supply can lead to. In addition to the economic component, the consequences of a power outage include social and environmental factors. And also we should compare it with other consumers. In the course of this study, we also developed such algorithms which can be further used in the planning and also in planning the further research of an electrical grid. Thank you very much.
Okay. So if there will be questions, we will send it to you by email. So greetings from the audience for your presentation. And unfortunately, due to technical problems, we missed one report. So we will connect with colleagues a little bit later. And this was the last report in our session. And it's time to say actually goodbye, but actually goodbye for our session, not for our conference, because at 16 o'clock here, and also again with the Zoom conference, there will be a special seminar about new challenges for energy company. And of course, you can join this event. You can participate, and we do not mind to invite you to the beginning of this event, where there will be the closing part of the conference, the closing ceremony. So at 16 o'clock, we kindly ask you to come back here, to come back to the audience hall, as well as to the Zoom conference. And now we have a small break. But before to say goodbye, I'd like to give a word to my colleague, Mr. Dmitry Kaplun.
Dear colleagues, thank you for your attention. Thank you for your questions, for our discussions, and we hope we will see you in the future. Thank you.
At 16 o'clock, we are waiting for you here.
Energy. But what is energy really? Is it the jolt of strength we get before we pass the finish line at the end of the race? Is it the inspiration we get when we see something new? Is it the tireless pursuit of trying to move forward? Energy is the power which drives our lives forward everywhere. We have learned to transform it from different sources and to use it at our will. We create energy and we give it direction.
All right, now hold it down.
We are the people who develop the future technologies today. What will they be like? It only depends on us. In the last decades, the vision of energy has significantly changed in many countries. And now, in this period of evident transformation, we can't miss the opportunity to find the answers to the most important questions. What drives the energy industry? What are the directions and tendencies of the energy industry? What lies at the heart of the frontline research? Which applied technology draws the most interest for the Russian industry and for the world industry in general? The leading world scientists, together with the bright minds of the new age from universities and international companies, every day are seeking the answers to these questions. The result of their work will be presented at this international scientific practical conference, Energy Agenda of the Future. We will take a look at energy from a different perspective, in an alternative way. Welcome to the International Conference, Energy Agenda of the Future.
So, dear participants, I'm happy to greet you one more time, and we spent magnificent 2 days full of events, full of discussions, full of reports, and we hope that you get some knowledge that you will share with others, and this conference is really useful for you as well as for us. And it's not the finish of our conference, because we will have one more event, interesting event. It will be the workshop for all of you presented here in the audience hall as well as in the Zoom conference. But as a small closing ceremony, we would like to introduce our head of the organizing committees and give them a word with small conclusions about the conference held. So I'd like to give a word to the executive director of the conference, Trifonova Natalia, director of Institute of Innovative Design and Technological Entrepreneurship at St. Petersburg Electrotechnical University, LETI, and to Dr. Professor Suslov, Konstantin Suslov, guest editor, senior member of IEEE, head of the study committee C1 System Development and Economics of Russian National Committee SIGRE, and head of the Department of Power Supply and Electricity in Irkutsk National Research Institute. So you may start.
Okay, dear colleagues, dear friends, we prepared the solution of our international scientific and practical conference, and we have some final words about this conference. And as the conference, its participant made the following decision. I'll read from my paper, and what can I say about this? The conference is considered successful, and its topics are extremely important for development of Russian and world science. There is a significant contribution of the conference to the development of the latest achievements in the energy sectors, as well as its socio-economic applications. Second one, deep graduate to the Federal Agency for Young Affairs for supporting the organization and holding of conference should be expressed. Number 3, a conference should be held jointly with the participation of the Faculty of Electrical Engineering and Automation and the Faculty of Computer Technologies and Informatics of St. Petersburg State Electrotechnical University. Next one. The next International Scientific and Practical Conference for representative of the community of young engineers in the fuel and energy complex is scheduled on December from 9 up to 10 2022 in St. Petersburg on the basis of the St. Petersburg State Electrotechnical University. One more. Okay. Okay, take the floor, please.
Specialist of a conference, 6-point cooperation with Springy Publishing House will be continued both on the placement of a collection of conference reports of Scopus and the attraction new foreign participants. 7-point, in connection with a planned increase in the number of conference participants, the composition of a program committee will be expanded for a more through scientific review of reports sent for publication. 8-point, the possibility of placing the best reports made at the conference in journal indexes by Web of Science will be considered. 9-point, final point, workshops, panel discussion, design and design workshops with participation of leading researchers from around the world will be provided in the framework of EAF 22. Dear guests, dear participants, I'd like to thank my colleagues from technical faculty, foremost Dean of Faculty of Electrotechnic and Automatics, Anastasia Skakun, young but very strong Dean in our university, and our colleagues from our university and our industrial partnership. And it's a great honor for me to declare for you our conference is closed. Thank you very much. Thank you very much. We will wait you in our conference next year.
Okay, thank you very much. I can say we have we made a successful conference. It's a very nice conference. Thank you, my dear colleagues. Thank you very much.
Спасибо огромное. Спасибо.
Thanks a lot.
The workshop about new challenges in energy company, and I'd like to invite the moderator of the workshop, Ms. AnnaKovaleva, Associate Professor of International Business Department at St. Petersburg State University of Economics. Please, our greetings.
Thank you. Once again, good afternoon. Dear ladies and gentlemen, my name is Anna, and I'm very happy and very proud to be here with you because I know that you're very smart and you have very bright heads. So I hope that today we'll not just discuss your presentation, but we make a trip to research and possibilities to communicate with each other. And firstly, I'd like to I'd like to ask Irina to tell us some words about your project in Rosatom, please.
Yes, please. I can use English or Russian. На русском возможно, да? Мне как раз сказали. Коллеги, если...
So, dear colleagues, can I have my presentation, please? It would be great. If not, it's not a big deal. So I'd like to thank you. I'd like to say good day, everybody. Maybe you can look at with my last name, Irina Sarkisyan. In any case, good day, everybody. Dear colleagues, I would like to tell about our guys who are going to talk today. They're also here in that room. They're also participants of the project, ambassadors of the Russian nuclear education. That's a project implemented by Rosatom for already the third year. Here we choose the most talented, the most active young people from the university because the average grade should be 4.5 points and above. The main purpose for those students is the popularization of the Russian nuclear education, and they have three main areas there. It's setting up events to popularize Russian nuclear education. It's a MEM, meaning promotion in social media, and development of project activities and development. And within the framework of our work, which we've got already for several years, as I mentioned, we've got quite good results because we see students, we see more students than before, as every next year. So the direct result is having more foreign students coming to us. We work at several levels. So you can see it here. I don't want to dwell alone upon that. This participant status is very important for our students and for us, for Rosatom in general. And also it's important for the university, but it also means activity and work with foreign students. There are some ambassadorship criteria. I don't think they're that relevant for today, but in any case, if you have any questions, you can write it to me. So any foreign students can be a part of that project who study in the, so to say, supporting universities. Talking about the specialties, we can discuss it separately, but of course, nuclear physics and technology is the first place. So if you have any questions, please, you can contact us and we will be thankful for that.
Like to ask you, what do you see in front of you? Balance, but what about connections of this balance with the project just as described by Irina and your research project? Your guess? Irina just has described the main idea and the goal of the project of Rosatom. And today, during this workshop, you are going to make presentation. What do you think, whether there are any links between the project and your report and these two balance? Okay, great. Any other ideas? Yes. Okay. Your ideas? Okay, exactly. So the first balance is devoted to your idea to be ambassadors of Atom, because you are linked together with the framework of Rosatom, and you are different. And the second one, this is your, let's say that this is balance represents various variety of your bright thoughts, and you are thinking about idea to make connection between your ideas. And in this connection, I propose you to make a short trip, not just to make your presentation. Let me distribute one paper, but not just a simple paper, but a magic one. So, dear colleagues, you'll see a paper. If you need a pen, just let me know, because we have collected. Do you need a pen or pencil? Or you have? Just raise your hand if you need. So I am out of pen. Sorry, I am out of pen. Okay. Sorry. I have one for you. Okay. So let's today not just make presentation, but find links between all your reports and your research or scientific fields and interests. And in this connection, we start with one of your colleagues in a distant mood in Zoom. Please, the first one will be your colleague. Yes, Irina.
The first one will be Somajit Mukherjee. Thank you.
Good evening, everyone. A very warm good evening from Moscow in your cold Petersburg. I hope you can see my screen.
Yes, but just made full screen Zoom. Okay, could you please just hold a minute, please? And you are kindly asked to make your notes just according to each presenter, and then in the end of our workshop, we'll discuss the results. Okay, is it clear as a task? Okay, so you see the list of your reports, and you try to find any ways of connection with this person who is presenting his or her report. And you say, I'd like to communicate and collaborate in what? In theory and methodology, in collecting data, in analysis data, etc. It's just your, not just imagination, but you're thinking what about your input in research of your colleagues. And then in the end of the session, we will see how rich all we are. Okay? Okay, thank you. So please, we are waiting for your report. You can start, please.
Thank you very much. So now we are going to talk about one of the most interesting and hot topics in the world of economics or commerce, which is going on right now, and that's cryptocurrency. I'm sure everyone who is sitting in the hall right now knows about certain cryptocurrencies, may even use cryptocurrencies or buy cryptocurrencies. So one of the issues that we are facing today in the world is how to power those cryptocurrencies, and that is my report today. Let's begin. So let's talk a bit about cryptocurrencies. Why do we need cryptocurrencies? As some of you may know, cryptocurrencies are about decentralization. The more decentralization we have in a network, the more there is power to the consumer. But obviously, if there is something which is not widely adopted, it's no use to develop it further. But as you can see from the graph, I hope you can see the graph, the rate of adoption of cryptocurrencies is much higher than the rate of adoption of the internet in the early 2000s. Right now, we are looking at a 63% yearly growth from 2021 to 2024 that we will see in the field of cryptocurrency adoption. While at the same point during the 1998 and 2000, we did not have even half of that growth in the terms of number of internet users. So that makes cryptocurrency a very important field to develop right now. You can hopefully have heard about some of the cryptocurrencies. You may have heard about Bitcoin. A lot of you have heard how expensive it is or how it's crashing sometimes. You may have heard about Ethereum, about smart contracts and everything else. You must have heard about stable coins, something called Tether, which are related to actual fiat currencies, and their value is related to the actual value of the fiat currency. So let's understand the problem that we are having right now in the world. As of this moment, the use of energy by cryptocurrency is equivalent to the use of energy by Argentina. Currently in Argentina, there are 46 million people living. Those 46 million people are using the same amount of energy Argentina is using in a year. So the problem we are facing is there's a lack of energy to power cryptocurrency further. For cryptocurrencies, there is a lot of energy required. We will discuss it further as to why there's so much energy required. But in the graph, you can see how much annualized terawatt hour of energy is required for cryptocurrencies. If you see the estimate, you can see that the cryptocurrency requirement is more than about 135 terawatt hours, and it's already more than Sweden and Argentina. But the actual maximum growth that we can see is even more than the growth for United Kingdom. So let's go on to the cause of the problem. Why does cryptocurrency require so much of energy? The problem lies in the very basis of cryptocurrency. It's called the proof of stake or the proof of work. So what happens is, in a very centralized system, there is a central organ which verifies and puts down all the transactions. So for example, if you go and buy something at a store, a bank is verifying the transaction has happened and is also putting a record of that transaction. But in a decentralized system, that is not possible because the central organ does not exist. To get over that problem, there is something called proof of work, where strong computers with a lot of high power output solve different mathematical tasks which require a lot of energy and give proof of a certain transaction. So that thing uses a lot of energy. Yes, there are other variable options called proof of stake, but again, even using proof of stake requires a lot of energy, since you still need to run those computers not to solve complicated mathematical tasks, but you need to keep a record of all the transactions that are happening in the network. So obviously, for any energy question that we are in the world facing right now, there are always two solutions. We can look at fossil fuels, as we have been looking at them and we have been using them for quite some time, or we can always look at alternative sources. I believe that throughout the day, you have all heard a lot about alternative resources and how they are powering the future. But obviously, a role of fossil fuels in the future will always remain. So let's see what alternate sources we can use in the field of cryptocurrencies. Let's start with the first and the widely recognized one. It is called geothermal energy. I believe that all of you as experts in the field of energy must have heard about geothermal energy before. And as of this moment, countries like Iceland and El Salvador are already using geothermal energy as sources of energy for cryptocurrency mining. This is not a very new system of mining cryptocurrency, but as we see in the example of El Salvador, which has already accepted Bitcoin as its national currency, that it can be an exciting aspect to develop further. Now, there are a few factoids about the geothermal energy, mining of coins through geothermal energy. When we look at all the mined coins in the world, 16% of those coins are mined through geothermal energy. And 80% of all the coins that are mined in the Scandinavian region, that is Sweden, Netherlands, and Iceland, are done through geothermal energy. In all these Scandinavian countries, there is an excess of 30 terawatt hour of energy output that they get from geothermal energy. This excess of energy can always be put in use for cryptocurrency mining. But there is a certain disadvantage for most other countries, and that is that it is not geographically available to all the countries. You need proper conditions like volcanic material and hot flowing lava under the water resources for that to get energy, and that is not available in most countries. So we must always look at the future and think about something else, and in our case that would be alternative source 2, which is nuclear power. I believe all my friends from Rosatom will be very happy to see this slide. And one of the things that it is being developed in the field of cryptocurrency right now is our SMRs and MMRs. SMRs are small modular reactors and MMRs are medium-sized modular reactors. These are small-sized reactors, so they do not require a lot of setup cost, or they do not require a lot of time to build up. A general scale of development is around 10 to 12 years of construction. That includes all the negotiation and all the budgeting aspects. And obviously, as anybody who works in the field of atomic energy will tell you, that this is the best and the cleanest source of energy for any use, especially in this case of specific use. Now we have a case example in our case, in our theory, which is the use of SMRs in the United Kingdom. In the UK, Rolls-Royce is developing SMRs specifically for powering small cities. Now in these small cities, they are theoretically saying that it will be possible to use the additional power that will be generated in these SMRs for cryptocurrency mining if the government of United Kingdom wants to do so. So there is a massive perspective in this case. Then obviously there is the point about solar power. If you look at massive projects that are happening in Tunisia and Morocco right now, in Morocco you are having the world's biggest solar power plant through solar panels. So you would realize that there is a big possibility in our case to develop solar fields in mega farms and giga farms required that will be used for, especially for cryptocurrency. The setup costs are low, obviously, but there's obviously a high environmental cost. So it's not exactly eco-friendly, but it is again a way that we can be thought about. So there is obviously need to talk about the future. When we're talking about the future, we must understand that the market for crypto-based decentralized finance is only growing. If we look at 2015, where the market was about $1.5 trillion, now it's already gone ahead a lot of around 15 to 20 trillion dollars. Now everything we do right now in this today's world is digitalized. We require a lot of energy for that consumption. And obviously, if there is something that needs to be developed, especially in the world of finance or economics, you require dedicated infrastructure for that to ensure that there is an uninterrupted supply of energy. So that will be all. Thank you for your attention. Thank you for listening. And I hope I will be waiting for some questions. Thank you.
Thanks a lot for very creative and non-standard approach to make a link between currency and energy. Thanks a lot for your vision. And dear colleagues, your question? Any questions? Yes, please.
Hello, my fellow ambassador. I have a question. You're suggesting alternative energy sources, but then does it not, how do I pose this? Is it not more expensive to switch over to alternative sources? And Bitcoin, okay, rather cryptocurrencies right now are not that huge. So the cost of us switching over, basically, you don't have profit from doing so.
That's all. Can I answer?
Yeah.
Yeah, thank you. So whenever you develop any energy resource, any, doesn't matter if it's for crypto or not, you always are looking at 10 to 15 ahead. For example, in African countries, I believe you are from some African country, they are developing nuclear power stations. Obviously, they are not looking at the energy requirement right now. They're looking at the environment requirement they will need after 10-15 years, since there's a high growth rate in African countries. For the same scenario, when you are looking at digitalization as a whole, I'm not even talking about cryptocurrency specifically, but as digitalization as a whole, you require new energy resources, which obviously require a lot of money, without a question. But that is not a sunk cost. That is an investment that you will get return in the future. So if you start developing those resources right now, 10 to 15 years, you will get a lot of return in that effect. I can give you a very good example right now in terms of Kazakhstan. After banning of cryptocurrency mining in China, a lot of cryptocurrency miners went to Kazakhstan and opened their business. Since Kazakhstan was able to add to their laws about helping cryptocurrency business to grow, they are now importing energy from Russia to give specifically for cryptocurrency mining. Now, you might think that is enough, but they also understand that the cost of buying electro energy is very high. So now, if you read the news recently, Kazakhstan has agreed to build a nuclear power station in Kazakhstan, and they understand that they will be using that energy in the future very soon. So, yes, that's an investment in the future.
Thank you.
We have one question from Zoom.
Yes, Alexander, please.
Hello, good to see you. And we have maybe one standard question. How do you think cryptocurrency will be real payment instead of real money in future?
Thank you for your question. I believe it is not an energy-related question, but definitely an economics-related question. Now, the fun part about exchanging money is that will it be actually replacing real money? I would say no. I would say confidently and completely 100% surely, I would say no. Because the fact is cryptocurrency as a whole is based on technology, and technology requires massive adoption. So until and unless the wide adoption of cryptocurrency itself, you cannot replace original currency. As a very simple example that I can tell you, I believe Alexander is from Russia, if I'm not wrong.
Yes, you're right.
So if you go to a small village in Russia, anywhere, small village, you will see that the people are not always the old people, the babushkas and the dedushkas. They are not all the ones who are using your NFC systems or the card paying systems. They are the ones who are using cash, because for them it is easier to use cash payment systems because it's more comfortable for them to use cash payment systems. And if there will be a time in the future when babushkas and dedushkas will be able to use cryptocurrency, which in itself requires a lot of technical knowledge right now, as it stands right now, then we can see that. But I don't believe that we will ever achieve that aspect. There's also the question of internet access, which you need for any payment to go through in terms of cryptocurrency. Even in Russia, throughout the country, we do not have a lot of internet access. Even if you go to developing countries, even if you go to, say, for example, from where I come from, India, we do not have. If you go to even poorer countries, for example, even if you go to Somalia, you will never get internet access outside Mogadishu. So obviously, cryptocurrency may exist as a parallel system of payment, but it will not exist as a replacement for general systems of payment. Thank you.
Okay, thank you. Dear colleagues, have fixed your notes about the first report, and I think that unfortunately the time is really limited, but in the future, just we're thinking that it will be we can open discussion about the best resource of energy, which energy is the best, nuclear or alternative energy sources in this topic you have described. But this is very philosophical and quite difficult to answer. Thanks a lot for your presentation. Yes. Yes, please.
atomic energy, as in nuclear energy or alternative resources of energy. Just want to clarify for the general audience that as far as the world is concerned, we look at nuclear energy as alternate energy because it is not green energy, but it is gray energy. So we have three layers of energy, which is called black energy, which is your fossil fuels. You have the gray energy, which is geothermal and nuclear, and then you have green energy. So we still look at nuclear energy as an alternative source of energy.
Thanks again for your very informative presentation. And now we are giving the floor to Mehmet with report accident tolerant fuel. Please, your turn. Okay, please. We are inspiring about presentation. Yes, please. And there is a clicky, so you can use it to change your slides. Please do remember about your notes for each speaker.
Здравствуйте, уважаемые участники конференции.
Hello, dear participants of the conference. My topic is Monte Carlo calculation of fission process for VVR 1200 with tolerance fuels. In the contemporary world, nowadays, many people have started noticing the global warming, carbon emissions, and other environmental problems. These are just a few of them. In order to reduce CO2 emissions and also reduce this global temperature, we can use nuclear energy more. But in order to do so, we definitely should make it as safe as possible. So, after the Fukushima Daiichi accident, scientists developed ATF, or tolerant fuel. So we use zirconium cladding, and in zirconium at very high temperatures, there is a reaction with water, with the water steam, and as a result, we get hydrogen, which is associated with elevated risk of detonation within the reactor. That is why tolerant fuel was devised, or ATF, which consists other alloys. So this material will reduce the risk of accident. So today I'm going to show a comparison of these two materials at the example of VVER reactor using the Monte Carlo calculation. This chart demonstrates assembly design parameters for our simulation model. You can see in the middle portion there is zirconium with the tolerant fuel. We also use chromium and aluminum alloy. This is a 3D model of our TVS, and I would like to show you the results first. This is burn up due to time, and we need to take into account the depth of this burn up.
Нет проблем. Мы здесь остались. И используя эту программу,
So using this program of Serpent 2 and Monte Carlo reactor calculation, I received the following results. You can see that with a tolerant fuel and without it, we have different parameters. Excuse me, they're similar because we used similar nominal capacity and similar time frames. And here you can see changes in the uranium-225. And this is the change within the parameters of uranium-235. And here you also can see the isotope changes of plutonium. And the last one are the fission products, xenon and samarium-149. In conclusion, firstly, the burn-up results are the same for each of the simulations. And frankly speaking, we saw these coefficients of effective neutron fission, and especially this infinite multiplication factor changes if we use tolerant fuel. That is why it is not economically feasible for the company. But this is absolutely safe, much safer. And we also saw this fissile amount, which actually changed when we used more tolerant type of fuel. This is associated with higher safety, but in the nuclear power stations, they of course must be competitive. And as this is not economically feasible, we cannot use tolerant fuels in the majority of generators. And also, we definitely need to save water and drink more for us and for future.
Your questions? Please, just hold a second, please.
Have you looked into the difference between these two materials? I mean, have you done any feasibility study? Why is it so associated with less profit? So first of all, you see this coefficient or infinite multiplication factor of neutrons. And you can see that up to the balance, we have for 300 days it works. So it's 300 days. And when we use tolerant fuels, this drops markedly. This parameter drops markedly. And before that, the time period actually shrinks. So
okay, my question is,
how a material
how does the material of the floor cladding and its thermal conductivity, and also the what's it called, the moderator, how could you infuse it into this amazing abstract to make it much more, to increase the tolerance fuels, thermal conductivity and capacity?
Firstly, я могу продолжить на русском.
I will continue in Russian, it's easier to me. This is an electron and physical calculation. That is why thermodynamic calculations for this parameter is not there. We just simulate the situation and understand that the exploitation is at the full mode. There are no deviations, and reactor works in the nominal capacity. For example, like thermodynamic changes, I suppose they can really improve the speed of thermal balance.
Is the change in safety so large that it would make the producers actually consider making these new ones? Because as you said, it's more expensive. So is the safety the change in safety, is it that large that it justifies the new cost of the fuel?
We use nuclear power plants for economic purposes, for the peaceful purposes. So that's why they must be competitive in the market. They must be cheaper than other power plants, thermal plants. So definitely they must be associated with a number of, with a certain safety, but they must be competitive. So at the moment, there is no answer. We have a question from Zoom. Alexander, you're welcome. I will immediately read out two questions. They both are short and brief. First, are you going to implement this project in some real-life projects? And also, don't you think that the use of tolerant fuel will be several-fold as costly? Tolerant fuel sounds good, but actually there is a risk of very high expenditure. I don't understand the second question. I will try to explain whether there is any risk that the production of such tolerant fuel will be way too expensive, much more expensive than the usual fuel. And generally speaking, yes, that's what I talked about in my presentation. This is new type of fuel. This is one of the variants because we used iron, aluminium, and chromium. And we can use other materials for safety, for safe exploitation of fuel in a nuclear plant. But we saw that this model is not economically feasible. It is not good economically speaking. And what about the first question? Any plans for a real-life implementation of your ideas? Tolerant fuels. For them, we have not only computer programs, but also it will be a completely new area for the nuclear plants, because increased temperature in the reactor, this is something that is associated with the biggest danger. That is why we would like to struggle with this problem, to overcome it.
Okay, yes, you mentioned something about chromium, and I couldn't help but ask the question. Chromium in nuclear fuel increases the brittleness of the nuclear fuel, which in turn increases reduces the thermal conductivity. And when it reduces the thermal conductivity, it means that it's more likely to crack inside the claddings and create much more like disaster. So what do you have to say about that?
Во-первых, этот вопрос связан с материаловедением.
This is something that depends on another study. There is a study in this alloy, as I can tell, and I can tell you, there are certain types, and generally speaking, you are speaking about the chromium at the moment, chromium alloy. We know that when we create alloys, we have much stronger material than the usual material from the customary components. Yes, this problem actually has already been resolved in a number of studies, and there are publications on this topic. You can find them on the net. And I have a question myself. So what about the functional and technical as well as economic properties? When it loses such type of properties, then how do you test different modifications? You spoke about the composition, and where is the limit when you say, yes, this is the best one for this reactor? How can we understand this? As a matter of fact, this is something that is also related to the electronic and physical calculations, and we are looking for different materials for the alloys, which would be ideal for these processes. We make different studies into different alloys, and after these experiments, we use the data for our electronic and physical calculations, and maybe some new discoveries. Okay, thank you. Discoveries, this is something that will really inspire us.
And please, dear colleagues, do remember about fixing your ideas to your presenters. Thanks a lot. Thank you. And now we like to invite Masha Laba. If I'm correctly pronounced, I'm sorry. With the report, proton beam therapy.
Okay, so my topic is outcomes following proton beam therapy. And why is this relevant to today's topic and today's themes? That is because, like, every year over 20 million people are diagnosed with some form of cancer. And what does this lead to? This leads to more utilization of cancer treatment, namely also proton beam therapy. But what I found was that proton beam therapy uses almost 4 times more volts as compared to traditional cancer treatment methods. So what is proton beam therapy? So proton beam therapy proton beam therapy is an advanced form of radiotherapy by which protons are used to target the cancer cells. And as you can see in the demonstration, we just have the radiation center, and then we have the target area which we'd be targeting. And then we have the history of proton beam therapy. So it was first proposed by R.R. Wilson in 1946. But then there was a long process of stagnation. Then it was only 4 years later where it was first introduced where it was first used in experimental science. This was to irradiate the pituitary gland, but it was still considered an experimental science. It was only almost 40 years later that it was used in a clinical setup. So this was the first ever clinical treatment of protons, where it was no longer considered experimental science. This was in Loma University, the Loma Medical Center, yes. And then, so now we have to talk about the physics of proton beam therapy. So as you can see from the illustration, we have the dotted line. The dotted line, that's going to be your proton, and then the solid line, that's going to be your photon, which also might be X-rays. So as you can see, like, this is dependent on depth. And so what happens is with protons is that because it has mass, it has specific momentum, and that gives us the opportunity that the dose that's going to be distributed is only going to be at the tumor and not the surrounding areas. Where, as you can see with the photon, it's being deposited at the center, which means firstly, we need to use more energy. And secondly, it also means that the person might be getting unintended circumstances from the radiation. So then what else do we get? We get what kind of cancers are treated. So like, as you can see, there's quite a number of them, but like, what's the common theme or commonality amongst all of these ones? All of these ones are all of these have this a similar, the commonality is that they all are critical organs or surrounded by critical organs. And as you can see in the previous one, the distribution of the dose was non-uniform, and some of the dose was at the beginning. But as you can see, like maybe for like a sarcoma, which might be deeper inside the body, you would need something that would give the dose within deeper, not on the surface. And then we also get then the outcomes of central nervous system, which is where the applications of proton beam therapy shines the most. But these are firstly like the negatives, but these results are better compared to X-rays and photons. So we get that the hippocampus would deteriorate slightly, and this would reduce in IQ levels. And then we also found that after 1 to 4 months, people had visible structural changes within the brain. And then other side effects were slightly more acute. So it was like acute headaches, visual deterioration, and so forth. So then what can we see? Like here in this one, we see how exactly it becomes. So as you can see from the proton, the first one, you see that the dose was rather, the first one is the photon. So as you can see, the dose is going beyond. The target was to irradiate the spine and the brain. So as you can see, the dose is going beyond the brain and stomach, and the brain and spine by going to the stomach. And as you can see, the dose is close to around about 15-20 grays, which is a rather significant amount, which in most people can lead to, if you were to get that in nature, you would be, the prognosis would be death. So there'd be nothing to be done with you. But obviously this is in safer conditions, so it is better. But then as you can see with protons, you can see that the dose was limited only to the target area with very slight dose being delivered outside of it. But then we also had stray neutrons, but also that is still lower than that of photons. And then we also have these ones which were showing the toxicity risk and chances of second cancer, which in children, which is where proton therapy is used the most, is something we have to consider. Children, we don't want our child after getting radiation to get a new form of cancer because of the radiation. So that's where it was used. And as you can see, it's significantly lower as shown by the blue line as compared to all the other forms. And in conclusion, we could see that yes, there were some issues with proton therapy, but overall it had lower negativities and toxicities, and now this can help us justify why exactly are we using a therapy that uses more energy than the other one. And that is the end. And thank you for your attention. Any questions?
Yes, thank you. Yes, we have one question, please. Of course, a very serious topic, and I just wondering about applicable this proton therapy for the illness of soul.
Yes, after we have one question from Zoom.
Okay, I'm listening.
Yes, Alexander, please, could you announce the question from Zoom? Alexander.
No, maybe from the audience, because audience was the...
Yes, Alexander, yes, we are waiting for a question first from you, please.
Okay. The question will be consist from two parts. I did not see that this method can be used for the stomach cancer. Will photon therapy have such possibility in future? Because stomach cancer is one of the dangerous and also cost for such procedure. Thank you.
For stomach cancer, yes, there are studies being conducted, but also like the issue with stomach cancer is that the cells within the stomach, which are lining the stomach, are very sensitive to radiation. So even with already traditional forms, it's still difficult to properly distribute the cancer, to properly irradiate the cancer, but it is applicable because of the dose accuracy. So yes, it can be applied to stomach cancer.
Alexander, and the second question?
And second question, how much is cost such procedure?
Yes, proton therapy currently is still very expensive. When I was studying it, though, it was only shown that it was commonly used by Caucasian males, and usually they tend to have insurance. So your normal, your normal person would not be able to afford it. So they need insurance, and it have to be premium insurance to be able to use this technique. But like the precise cost, I could not find it.
Okay, thank you for questions. And we have one question. Okay. Please.
Okay. I'd like to know what are the success rates of this procedure compared to the others?
Success rates are comparable to that of, what's this? X-rays, X-ray radiation, brachytherapy, and so forth. They're comparable. And in some cases, it was more successful because, as I said, in this one, as I said in this one, the left one, it shows like the second cancer risk chances, and it shows there's lower chances. So if you were to consider second risk chances, it would be more successful in that regard.
Okay, thank you.
Okay, thank you, dear colleagues. Thanks a lot. You have, okay, please, could you please, one, two, but dear colleagues, we are really running out of time, so please pose your question be short, please.
Okay.
Thank you.
I'd like to ask, how do you know the amount of photon to, I don't know, how do you know to, I don't know the word to use, the amount of photon needed to cure a particular size of cancer? Because we have different sizes, so how do you know?
Okay, so that would be more of a dosimetric, that would be more to what oncologists do. So for them, during the studies, they do know, maybe for like, because if it isn't like if you lose electrons, if you use protons, the dose would be very similar. So like it'd be very size specific, and the kind of sensitivity the specific cells you're targeting has. And also because cancer cells tend to have higher sensitivity because they're constantly in a mitotic phase. So like it'd be through calculations, when you do dosimetry, and oncologists, they would know what dose, what level, what energy do they need to deposit.
Thank you. And we have one more question, please. No, okay. Sorry. In any case, you have quite a lot of time to communicate with each other. And after this, let's say this, fixing your ideas on this list, you can share your thoughts. Thanks a lot.
Thank you.
Thank you. And now we are giving the floor to, is for Iskander, please. And you have time between presentations to fix all your ideas to the previous presenter, just to put your notes and comments about your possible collaboration. Коллеги, мы вас слышим. Кто в чате, somebody in chat. Now it's okay. Please.
Значит, сегодня я хотел бы вам рассказать про применение возобновляемых источников.
Today I'm going to speak about the application of renewable energy sources for production of ecologically clean fuel. So this is, first of all, a type of energy which is received from sources which are renewable. For example, this is hydroenergetics, wind, wave. Also, within my talk, I would like to speak about my tasks. Also, I would like to speak about the sun and hydrogen type of energy, as well as the application of renewable energy sources. Renewable energy sources in the majority of cases do not have any negative impact over the environment and ecology as such. And this is their advantage if compared to non-renewable fossil fuels such as oil, gas, and coal, which cannot restore naturally. Despite this, renewable energy sources are also associated with certain disadvantages. For example, the wind and solar energy can have interruptions in providing its flow. So in the majority of cases, it would require a great deal of water resources if we speak about water energy, which can result in floodings, but these negative impacts are significantly insignificant if you compare this to fossil fuels combustion. That is why renewable energy sources are ever popular in the contemporary world. For example, back in 2019, 2.8% of the world's energy consumption was received from green sources. For example, let us look at the results of some contests among the photoelectric energetics between 2018 and 2020. As you can see, the cost of 4 kilowatts per hour can reach 1 cent, 1.35 cents. The Federal Polytechnic Lausanne School assembled such solar hydrogen energy system, which comprises a solar battery, also a tank with water, nickel electrodes, and a membrane which separates oxygen from hydrogen with high ion conductivity, and the molecular hydrogen or oxygen cannot penetrate in the cathode and anode areas. Within this system, the transformation efficacy accounts for 14%, which is the best indicator or the best parameter among all the existent devices of this sort. In the daytime, the batteries, solar batteries provide power, which feeds electrolysis of water. Hydrogen accumulates in tanks for further production of power in the nighttime. Despite the nickel over tension, nonetheless, there is good hydrogen accumulation on the cathode. As a result, this hydrogen can be used as fuel. In 2020, one of the biggest companies in the world, Airbus, provided a concept of 3 passenger liners, which can be running on hydrogen fuel with 0 CO2 emission. All of the planes are called zero turboprop and turbine-like engine. Their capacity is over 200 passengers, and they can fly over 2,000 kilometers. They are based upon combustion and also turboprop and turbine-like engine can carry up to 200 passengers, and the last one, turbine wing body, with a fuselage and the capability of going as long as 2,000 kilometers. In conclusion, I would like to say that apart from the aviation, at the moment, hydrogen fuel can also be used in automobile manufacturing in order to create cars, because this is one of the most ecological solutions for this problem.
Thank you, Iskander. And do we have any questions from chat, Alexander?
Yes, there are questions. I will ask you a question myself, because the presentation by Iskander is actually very interesting, especially in terms of aviation. Kindly tell me, Iskander, you proposed a project of vehicles, air vehicles, which will be running on ecological hydrogen fuel. Kindly tell me, do you think that actually the cost of pumping this fuel will be significantly higher than the servicing cost for today? Do you see such risks? I consider that hydrogen fuel today is associated with significantly high price, but with the development of renewable energy sources, as well as the development of solar energetics, I suppose the cost for hydrogen fuel will go down because it will become much more popular, which will reduce the price for sure. Thank you.
And now we are giving this opportunity to present a report to Lema Lekonseva Daniel, if I'm correctly pronounced you. I'm sorry. I just wondering that countries, they compete about producing efficient in economic terms fuel you have described in your presentation. So it's a very difficult competition, sorry, because countries, they compete in this market.
Всем видно? Так, сегодня я вам буду рассказывать о интеграции.
Today we'll tell you about the integration of nuclear energetics in the developing countries. My presentation is going to be made of 4 parts. The first one is the benefits of nuclear energetics. Second, this is about IAEA projections for the nuclear power, and nuclear energetics for the developing countries is the third part. What are the advantages? And in the last part, I will be speaking about the requirements that and standards that the developing countries should comply with in order to apply this nuclear energy in their countries. Now let's speak about benefits from the nuclear energy. Here we have the AQI index. This is the air quality index, because this is related to the air pollution. What are the benefits of nuclear energy? First of all, it says low impact, high performance, a small amount of land. What do I mean by low impact? It's not that they stop emitting CO2. In the process, they don't do it. You should definitely look at the cycle of nuclear fuel production, also this type of equipment and so on. But there is an interesting fact. The CO2, which is emitted by the nuclear energy, can be compared to the CO2 that comes from different nuclear sources or renewable sources. For instance, IAEA made a post in 2018, Climate Change and Nuclear Power. It was titled, and it demonstrated that there is a certain amount of grams which are going to be emitted for each kilowatt of energy, of electricity. So for the nuclear energy, it accounted between 10 and 15 grams of CO2. For the solar energy, it accounted for from 40 to 50. So it's higher. And for carbon, it was 950 grams per each kilowatt. So you can understand that the nuclear energy is quite low in this respect. And also the wind energy, it was from 8 to 12 grams per kilowatt. What do I mean by high performance? 1 kilo of uranium, which will be enriched by 4%, will provide us with the energy which will come from the full combustion cycle or full production of 60 tons of oil. This is very high amount that we can receive. Nonetheless, also we can say that it's not just high energy and low emissions of CO2, but also it can be done in the very, very small, in a small sites or small amount of land. I talked about climate change and nuclear power, and this is an article which IAEA published in 2013. They stated that to produce 1,000 megawatts for the nuclear energy, they need actually from 1 to 4 square kilometers. What about the solar energy? From 20 to 50 square kilometers. For the wind plant, from 50 to 100 square kilometers, and so on. So actually, the nuclear energy is associated with good and sound benefits if compared to others. Also, I would like to say that Mikhail Chudakov, I hope that I will remember what I meant here, the Deputy Director General of IAEA, and also at the moment he is head of the Nuclear Energy Department of IAEA. He once said that only nuclear energy performs or complies with 3 goals of sustainable development. The 7th, this is clean and affordable energy. The 9th, industrialization and innovation and infrastructure. And the 13th, climate action. This slide, 6 gigatons were saved. They were not emitted. According to IAEA study in 2019, within the recent 50 years, only thanks to nuclear energy. What does it tell you? Nothing. In fact, if you don't know that last year we emitted 33 gigatons of CO2. So within 50 years, we managed to reduce this amount, and we try to enlarge this amount. I would like to remind you that this CO2 is a greenhouse gas. What is air quality index that I have already quoted? I would like to say that according to WHO, over 7 million people died because of air pollution. Then I decided to consider how the nuclear energy helps here. For example, there is an index that shows air quality. It actually takes into account particulate matter, solid particles, which stay within our lungs, something that we can get in closed space, for example, and also the solid particles of hydrogen are also taken into account, also nitrogen oxides and other greenhouse gases. The idea behind it is that there are 6 levels. Each of these levels is more dangerous than the previous. And let's start with the upper. The first tier is sort of good. Out of the microphone.
Yeah, sure. Okay.
Now here we have 6 years, and I would like to say that according to IAIE, according to WHO, these developing countries have the same air quality as can be observed in the industrialized nations. For this, I would like to start with the nuclear energy. So you can see that the forecast at the best case scenario will be 92 by 2050. At the worst case scenario, it will be 392. And I'm actually short of time, so I will skip it. Now, nuclear energy for developing countries. If they want to do it, then the country must definitely stress it, write it somewhere, and also give a note that they want to use nuclear energy as a way of alternative energy for them. What do they need to do for this? First of all, the nuclear infrastructure will be developed, but I don't want it to be considered as a problem. We don't need some adequate infrastructure, but it's an opportunity rather. It's not a challenge, it's an opportunity to develop new areas and to receive nuclear energetics. For example, in Bolivia, there is a research center which is constructed. And for now, actually, this country cannot have a nuclear reactors, but nonetheless, they have created all the conditions in order to set up such type of reactors further. What else will it be? It's trained staff who will be capable of creating, and not only creating, but also developing this area in this country. What do we need to do further? There will be 3 restricting factors. First is finance. It is really costly. There are studies that show that approximately 80% of all the expenditure for the nuclear infrastructure is done in the very beginning as investment to set up a nuclear power plant, and also to close it further when its lifetime expires. Also, we cannot create it out of nothing. We need to have regulations in place. We need to have different organizations which will regulate everything and capable of working with nuclear energy. We need to have rules, standards of exploitation, and also something that everything that can be done, also trained staff. We need to do a lot with the trained staff. We can develop not only nuclear energetics, for example, the nuclear infrastructure of IAEA helps us with this. It can help any country. The finance depend on every country, but the personnel also may develop, may depend on the country. Sometimes there are actually people who travel for getting trained or education to other countries. Yes, I have finished. Yes, we have one question. Kindly tell me, in what country the use of nuclear energetics happens most efficiently? I would say in France. About 70% of all the nuclear energetics. I don't know what you know about ITIR. So they actually have different projects, ITIR, and also France as a country is going to develop small modular reactors and going to make money with this country who has 70% of energetics, and who they take part in different projects and they develop everything neatly. So that's why I consider that it's France.
Thanks a lot, Danielle, and I'm very sorry I skipped the orders about sharing gas, right? If I were correctly, gas, yes, thank you. And but advisory that France has a long story in nuclear energy, and they have transformed their strategy in this field a very interesting way. Okay, thanks. Colleagues, please remember about notes. It will be the present to each other in the end. And please, 4 minutes. And because you know that in business, if you have two minutes to present and to sell your offer, so sell your offer to your audience.
Okay.
Okay.
So hello everyone, I am Shirin Gat. I'm a representative of Opnics Institute of Nuclear Bioengineering and also ambassador of Russian nuclear education. My research work is about the AB1000 reactor and its 3D model of fuel assembly in Serpent. So my content for today is I will talk about the goal of my scientific work. I will make an overview of AB1000. I will tell more about what's the Serpent program that I'm working in. And I will show you the output results of the geometry fuel assembly of AB1000. So my goal of scientific work is focus mainly on the overview of AB1000 and the stimulation of AB1000 on Serpent. And the task that must be completed in order to achieve this goal, I have to make a geometry for the fuel assembly and reactor core, and also to calculate the neutronic calculations like multiplication factor and reactivity to ensure the safety of this reactor to be able to be in operation. So what's AB1000? It's a nuclear power plant that's sold and designed by Westinghouse Electric Company. It's a type of pressurized water reactor. Actually, there is now 6 AB1000 reactors, like 4 are located in China, and there's 2 reactors under construction in USA. The AB1000 has 35 fewer bombs and 80% less safety piping. And you can say from this that AB1000 is not safe enough, but actually the less number of pipes is more safety margins that the reactor has, so it's safe. So the design characteristic of AB1000, it has about thermal power of 3,400, efficiency of about 32%, and the fuel used is uranium dioxide. And the coolant and moderator of this reactor is light water, and we have a cladding of zircon. So what is the Serpent program? Serpent program is a 3-dimensional continuous energy Monte Carlo reactor physics code, and it can be used for various reactor physics calculation, like at the pen and fuel assembly, and even for the reactor core. So for geometry modeling of the reactor in Serpent, first we have to divide the geometry into separate levels. First we identify the pellets in the program, and then fuel rod, and then the fuel assembly, and then we get the model for the reactor core. These output results of the fuel assembly AB1000 I got in the work of in Serpent program. The fuel assembly got like about 264 fuel rods. And you can see that from reactor core model, it's shown that it has different type of enrichment. It's shown the different colors. It shows like it have different enrichment, like from 2.35% to 4.4%. And also I got from the stimulation in Serpent code, the multiplication factor, effective multiplication factor, it's about 1.1, and which is a good result actually at 0 power of the reactor. So conclusion is that AB1000 is cost competitiveness because it has a very simple design. As I said, it has fewer pipelines and safety pumps. And also you can see from the above slide that I have got the result of the geometry of fuel assembly of AB1000. And also the reduction of these safety pumps make the AB to work for about 60 years. Okay. Thank you.
Thanks a lot for
And
your.
I will be happy to answer your question.
Yes, thanks a lot. Questions, colleagues? No, because I'm sorry, but Shirin, you really described really interesting case of very efficient in terms of economics of device. So it's a great experience, I think, to share this information. Yes, you have collaborated. You should collaborate. Yes, so please, yes, you have a question? Yes, it's so interesting.
You sparked my interest. So what would you say could be done to increase the thermal conductivity of nuclear fuel uranium oxide? What could you say could be done, and how could we create a more universal, because the coolant for reactors in which the nuclear fuel is uranium oxide is water, right?
Yeah.
So how could what could we do to produce a much more better interaction between the surface of the fuel rods and the water? What could we do to improve the thermal conductivity and the transfer of energy?
That's why we use the cladding, which prevents the corrosion of the fuel rod, and also it prevents the leakage of the fuel from the fuel rods and from the reactor. Zircaloy.
Okay, thank you. And Alexander, could I ask you to collect the questions from and we address to our colleagues? Okay. And the answers for the questions. Okay, thank you. Thanks a lot, Shirin. And now the next presenter and speaker will be Baldorie, if I'm correctly pronounced. So Baldorie is going to sell her research project in 2 minutes. Try.
Здравствуйте, уважаемые участники конференции. Вашему вниманию предлагается работа на тему.
I would like to give you an account of the analysis of the effectiveness of measures to reduce active power losses. This is a short presentation for Mongolia. Mongolia has no outlet. The square meter, the square area is quite large, with quite sparsely populated, and you can see here our capacities, that the energy that we need, approximately 75% of energy is consumed in Ulaanbaatar. You can see here the map of energy system of Mongolia.
Сети Южного района, которые составляют приблизительно 4873 километра высоковольтных линий электропередачи. Так, в Монголии электроэнергия.
So in Mongolia, energy is provided by the internal energy production. We have 7 electric power stations, and we also have a number of smaller ones, and wind, solar, and hydro. Approximately 13% of all the energy necessity capacity is also provided from Russia. And the mines in Mongolia are also provide energy, and we have direct projects with China. There are certain disadvantages of this energy system. This is low load, and also very prolonged electrical lines, very low generation, and which is also distributed in electricity networks and electrical grids. Now you can see these losses during transmission and distribution of electricity, with the highest value within the recent 20 years in 2002, approximately 20%, and 5.7, the lowest one, in 1986. As an example, I would like to show you an electric network of the western part of Ulaanbaatar, which includes heat and power stations. This is an electric diagram. For this particular diagram, we calculated the main modes. After all these calculation of main modes of operation, the summary was approximately 624 megawatts. This is the summary capacity. We calculated the opportunities of reducing. This is the slide that shows our calculation for the of the electric grid recalculation, and also this slide shows our calculation after we structured additional high voltage lines. In our conclusion, for each of these variants, we also made particular calculations, and from each of these calculations we can come to the conclusion that the batteries of condensation, of electric condensation, are most feasible in terms of economy, but the payback period is approximately 4 years. According to the electric calculation, the loss will be significantly smaller, and for our event, it is considered to be ineffective. So on constructing the new lines, in the two chain, the loss will be smaller. But if you take into account the economic parameters, then the payback will be even smaller, and we can come to the conclusion that for this grid, there was one chain electric conductivity with one chain. I'm happy to take your questions now. We have a question in Zoom, whether you plan a construction of a new station in Mongolia. Do you know anything at all about it? This is one of the most interesting questions for me either. As far as I know, we haven't looked into this issue, and I hope that in the nearest future, there will be some joint project with Rosatom.
Okay. Now you know how to sell your research in 2 minutes. Okay, so now we are going to Lita Bada. No, sorry, to Dauda. Sorry. Sorry, excuse me. And if you would like to know more about energy, nuclear energy, or future of nuclear energy in Mongolia, you know who is expert in this field. You can ask.
Good day, everyone. Today has been an amazing day for me, and I would like to just go into my topic right now. So the topic of my research and my paper is basically the determination of micro-hardness of alloys of aluminum, silicon, and germanium system of various compositions. So aluminum alloys are very important because of their high resistance to corrosion and thermal conductivity, and they just suit a lot of industrial purposes that we cannot even begin to fathom. However, the main aim and objectives of this research or work is to analyze the effect of silicon and germanium on the micro hardness of aluminum alloys. So we are going to, what we're going to do during this experiment is add various differing percentages in mass of germanium, manganese, and silicon into alloys of aluminum, and then we're going to see what effect it has on the hardness of this alloy. So let's begin. So these are the four. Sorry, is there something wrong with my voice? It seems to be echoing. Okay, these are the four samples that we had. And quickly, I'll just show you the triangular representation of the phase diagrams for aluminum, silicon, and germanium. And so we have them at different percentages and compositions. And you will see that there is a shift in the phases and just different peaks and different peaks, maximums in these pictures as to what that actually differs from the square diagrams that we're used to seeing. This is a much more complex diagram than the two-phase diagrams that we are accustomed to seeing. So let's go to the next page, to the interesting part, Now, this is the first composition. You could see, is there a way for me to enlarge this diagram? You could see, is there a way for me to zoom in? Zoom into the picture. Please, could you help me zoom into it? Enlarge it.
I think it is not possible to do it. No, it's not.
If you see there are black phases, we have the white phases, and we also have the much more needle-like phases where it's not really clear if it's black or white. Now, what we did was we used a load of 0.05 kilograms force to apply and create an indentation on these phases. And what happened was that we measured like the diameter of this that was formed by this indentation, and then we compared it to the previous. We did it for, let's say, twice. We did it twice on different spots, right? And then we compared them, and we tried to divide it by the original diameter, and then we came up with the load per area, which is the pressure, which is the hardness, the toughness of the material. And so we were able to come up with conclusions based on these these pictures you see on the screen. Now the next one is the second sample. So the second sample, we had just 3 phases as well, but as you can see, the difference here is that here we had 60% of aluminium, and here we have 56. But you can now see that we have much more scattered needle-like phases than we had in the first one. Now you have clear white phases, but now you have much more scattered, rumpled, oat-like structure. That is because of the reduction in the aluminum content and the increase in germanium content. And what happened to the hardness? Let's look at the hardness here, HV. What happened to the hardness from the first to the second sample is we had a hardness of the black phase at 259 kilograms force per millimeter square, and here we have 100. We have 100. So I'm not going to draw conclusions yet. We will do the conclusions at the end. So just try to notice that we had 58 in the first, and we have 74 now. We had 66 in the needle-like parts, and we have 86 now. So let's move on. So we can see that there is an increase in the black. There's a decrease in the black phases and an increase in the white and needle-like phases. Let's go to the third sample. The third sample is we can see the same change actually. It reduces from 100 to 99, and it increases from 74 to 75, and then and the third part increases from 86 to 94. But what happened this time? What happened this time was that we imputed manganese into the equation, right? So to the fourth sample. The fourth sample is, as you can see, the phase diagram. We had the black. We had more. Actually, this was the most interesting part, because we had more phases. We had the black phase, we had the white phase, we had the needle-like phases, and then there's a ring-like phase that was white that surrounded some phases, which we were not really able to. If you look at this part, you could see this is looking like a phase of its own, right? It's appearing in different parts of the images. So that's what happened, and you can see that the force per meter increased to 563, 67 in the white phases, 63 in the white phases too, the second type of white phases, and then in the needle-like structure we have it increasing to 111. And so now let's draw conclusions from this. The conclusions are that when there is an increase in the concentration of silicon, right, and in germanium or vice versa, we have an increase in the strength and hardness. So the strength and hardness is determined by how low it actually is, not by how high it is. Because if it's higher, it means that it is soft, right? So what it means is that the needle, the indentation, was able to pierce through the material much more easily, and that's why you have a high ratio. That's why you have 500. You have high values like this, right? But when it's tougher, you're going to see low values like 67, etc. So the dark phases, we have increase in strength and hardness due to the constant replacement reactions of germanium atoms and those of silicon. So we have defects in material science that help to strengthen materials. Defects like done by replacement, not the points difference, because vacancies don't help strengthen materials. What could help you strengthen materials are defects like rolling and interstitials, right? So when you have interstitial, it strengthens materials, it makes them tougher. And the dark phases are phases with silicon. Based on what we got to research in the lab with my supervisors, we came to the conclusion that the dark phases contain silicon. The second alloy are aesthetic, but the first, third, and fourth are near aesthetic with a little inclusion of the black phases. And so because the black phases in the first second was the least. So the hardness of a phase depends on their components, and the hardness of a black phase increases with the increase in silicon components, and white phases become harder with increase in germanium components. So drawing these conclusions, we were able to figure out how could we make an alloy much harder than it is right now. And we are able to we are still in the process of experimenting with more materials. And so hopefully the next performance I have is going to be on a different aspect. Thank you.
Thanks a lot, Dauda. And do we have any questions in chat, Alexander?
Yes, we have one question. Thank you very much, Mr. Kazazabrank. Interesting presentation. What kind of software did you use for creating these interesting sample pictures on your slides?
Honestly speaking, it's an amazing electron microscope that we have in the lab. It's from a German company. I think is Nichek, something like that. I can't pronounce the name, but it's high tech. It's one of the best in the world. So yes.
Okay, thank you.
Thank you, Dauda. Thanks a lot. Thank you. And now we invite Litan Daba. Please. So if you'd like to be inspired by experience and using very sophisticated equipment, please address your question to Dauda. Now, to be honest, we envy that you can use this microscope to see these pictures like this, like you showed that. Okay, please.
Thank you. Good afternoon, rather good evening, everybody. My name is Litan Daba. I am from the Ordnance Institute of Nuclear Power Engineering. And today I'll be presenting on predicting the crisis of heat transfer in nuclear power plants via acoustic methods. So today I'm just going to briefly touch on everything. I'll try to keep it quick since we don't have a lot of time. So I'll go through the introduction, the goals of my work, the analysis of the data and results, and finally the conclusion. Okay, so predicting the crisis of heat transfer in a nuclear power plant via acoustic methods. For a reactor to operate in a steady state, all of the heat released in the system must be removed as fast as it is produced. This is accomplished by passing a liquid or a gaseous coolant through the core and through other regions where heat is generated. Just a second, okay. Owing to the limited visualization of the boiling surfaces and dependence on temperature monitoring only, boiling systems are now running at relatively low heat fluxes and operate at lower power ratings to provide ample safety through ample safety margin and thereby prevent such a scenario from occurring. So beyond just using temperature monitoring, what's another way that we can do detecting? Well, acoustic boiling detection is a solution because sound travels through the coolant, and an acoustic boiling detector will be able to detect boiling at any location. It can work in high temperature conditions, and it can easily be replaced in the event that the performance becomes degraded. And lastly, studies have indicated that a continuous acoustic mapping during boiling can be used as a tool to predict the impending critical heat flux in boiling systems. I won't really go through this whole entire diagram, but this is the Nukiyama boiling curve for those who are interested. And it basically describes that CHF is a condition of boiling where there is a sudden loss of contact between the boiling liquid and the heating element, which in the case of the nuclear industry is a nuclear fuel rod. This instability can emerge suddenly and in response to changes in power levels, for example. So basically what happens is that there are large lumps of vapor columns that form on the insulating vapor film, and it prevents the wetting of the heater surface. This insulation of the surface causes the temperature of the surface to rise drastically, and it can cause a meltdown or material degradation. This maximum heat flux at the point where you can see now in the diagram C is known as a critical heat flux. So the purpose of or rather the goal of my work is to predict the crisis of heat transfer in a reliable way. So I'm utilizing various programs and numerical computing platforms to study the behavior of boiling crisis. Just the data that I'm utilizing in this study consists over 3,000 recordings. And for the purpose of this presentation, I've taken about 5 of them and taken a couple of samples from each of them. So the sort of computing that I'm using, it's MATLAB, some data analysis programs within R, as well as different mapping programs. So as I said earlier, while the heat flux continues to increase, bubbles start to emerge with bubbles on the neighboring nucleosides. So based on the principles shown by Krant and Finch, one can determine when bubbles start to emerge by observing higher secondary amplitudes in acoustical data. So for me, what I did is I took the data that I got, the initial data, and I transformed it using fast Fourier transformation. So I could represent this data in the frequency domain and thus determine which data was showing second higher subsequent amplitudes. So currently, my next task within my work is to now develop an algorithm to determine this autonomously and to build a mathematical model around this. So the conclusion that I can draw right now is that several studies have been focusing more on the acoustic signatures which are emitted during the boiling, but not a lot of them focus on the moments just before the boiling. So I have decided to continue in this direction because the prediction of the critical heat flux or when boiling crisis occurs is the most important part in it. Thank you.
Thank you, Lita. Thanks a lot. And Alexander, do we have any questions in Zoom?
Yes, one question we have. Thank you. Interesting idea. The platforms which you're investigated have monitoring systems, software, sensors. Thank you.
The monitoring system that we're currently using, it's a hydrophone that we put next to, well, I can't really describe it that much, but next to the pipes. And the one that I do wish to use in the future is to use machine learning programs to create a neural network that can predict it.
Okay, thanks a lot. Thank you. And the last presenter speaking, Evgenia. So if you'd like to be familiar with many invaders, platforms, softs, please ask Lita, who is expert in this stuff. Okay, Evgenia, the floor is yours, please.
Thank you. I'm Evgenia, a student at Towns Polytechnic University, and today I'll be presenting on the effect of radioactive sources on gamma radiation monitoring. So at the end of this presentation, we'll determine whether there's a need to check on the type of radioactive sources that is used for a calibration of a sodium iodide detector before using it for measuring gamma radiation monitoring. So one of the detectors that is being used for gamma radiation monitoring is the sodium iodide scintillation detector. And its disadvantage is not its low resolution, but rather the temperature fluctuation, which mostly leads to shifts in the peaks that are being produced when we use it for gamma radiation. So we mostly calibrate these detectors using radioactive sources to rectify this shift gain. So the main objective of this particular presentation is to investigate the impact of sodium iodide detector calibration on gamma radiation monitoring. So in order to achieve this main objective, the following tasks were performed. So this slide shows the scintillation detector that was used for gamma radiation monitoring or for this particular experiment. So it's the BDKG03 scintillation detector. So for the research method, what we did was we calibrated the detector using both a low radioactive source and also a high radioactive source. And after that, we used this detector to investigate the correlation with changes in the meteorological parameters of low dose rates background in the city of Tomsk. So after obtaining the measured result, the measurement, we then plotted the following graph. So the first graph shows the variation or the dependence of atmospheric temperature versus that of the daily variation of dose rate measured when we used the detector when calibrated with a high radioactive source. So from the graph, we can see that the measurements were close to each other, which is not supposed to be the case because theoretically temperature does affect reading. So they are supposed to be further apart from each other.
And we then plotted a second graph, which is the B, which is we compared the daily variation of dose rate when we use the high radioactive source calibrated detector and also the low radioactive source calibrated detector. And from the graph, you can see that they are further apart and they are not close to each other. The next graph, we plotted the daily variation when the detector is calibrated with both the low and also the high radioactive source. And we compared both cases with a constant coefficient for low dose rate measurement. So from the graph, we can see that the low dose rate was very close to that of the constant measurement for low background, but there was a deviation between that the detector when it was measured with a high, when it was calibrated with a high radioactive source, and also when it was compared with the constant coefficient. We can see the same trend being applied for also the annual variation. Also, we can see that the annual variation for the dose rate for the detector when measured, when calibrated with a high radioactive source, being deviated from the constant coefficient for low background radiation. But for that of the dose rates, when we calibrated the detector with a low background, was closer to the constant coefficient of the low background. And lastly, we then plotted a graph of the temperature coercion coefficient when we calibrated using the low background to that when we calibrated using a high background. And we can see that from the graph, the one that was calibrated using a low background was very constant as compared to the one that was used with a high radioactive source. So this shows that if we really use the correct detector for the right source, we'll end up getting like it wouldn't really affect temperature, wouldn't really affect it as compared to when we use it for wrong measurement. So in conclusion, we can conclude from our results that when there is a need to calibrate detector before using it for measurement to rectify the temperature shift on the peaks that are used for measurement. And also when we do that, we also have to check the type of radioactive source that is being used for a particular detector before using it for measurement, or else the result that we'll end up getting will be wrong, and we'll end up getting wrong measurement when we use it for scintillation, when we use it for gamma radiation monitoring. Thank you.
Thanks a lot. Thank you, Evgenia, for very sophisticated, interesting report. Alexander, do we have any questions?
Yes.
Yes, please.
Thanks for your idea about monitoring and calibration. How often do you need to calibrate the sensor and detectors? Thank you.
Okay, we calibrated it once, but for a very long period of time. So we use a climatic chamber for that of the low background, and we use a maximum of 5 minutes for every measurement. So we took a lot of measurement with different temperature. And also for the high radioactive source, you use the same. So the longer you measure, the accurate your results.
So if you're enthusiastic, yes, if you're enthusiastic to make a long research, you know who is expert. Evgenia, please. Ask Evgenia. Thanks a lot. Thank you. I think that it's not, thank you to be short. I think that it's quite difficult to be the last presenter because there are a lot of information behind, in background of your presentation and behind your speech. Thanks a lot, dear colleagues. I'm very sorry, extremely sorry personally for time, but now you know that you are very rich and rich by what? By doing your research. And now I ask you to collect your papers and just to make screen on it, just make photo and share with yourself. So you can see like, it's like a message to collaboration, and you see in which way you can communicate with your colleagues. Irina, you'd like to tell some words to okay. Thank you, colleagues. Do you have any questions, comments, your feelings? Now you know that you're real experts in many fields. You're very smart. And I have a feeling that you really like to talk more about your research, about your experience. Now the floor is yours, and it's up to you to organize communication between with other colleagues, and not only between yours. Sorry, between you. Okay, thanks a lot, and we hope to see you once again. And thanks audience in Zoom for your very interesting questions. Thanks a lot. And thank you for entrepreneurs.